is analog electronics? Is an electronic system where signals analog signal is a signal whose amplitude can take between the given limits. Continuous signal, that is analog circuits operate on. Now coming to digital electronics, it is electronic study of signals. A signal whose amplitude only gives between the this operate signals. Coming clock. Clock is a periodic rectangle. You basic. From this we can calculate the duty cycle, that is duty cycle for a periodic digital signal is, it is the ratio between high level time, that is on time, high level time, and the ratio between low level time, that is off low level time. The on time is said to be period. On time we call it as TH high, off time T low time. Total this is period. From this time period. That is duty cycle is calculated as duty cycle H divided by total time T. As duty cycle for is calculated as TL divided by T, total time. This is how to calculate the duty cycle. Let's see what is a digital circuit. Having inputs, only is called a gate. Or more, any number of inputs is a switching or any kind of two-state circuit, that is on state, off state. We are having here basic gates, universal gates. We'll see what is basic gates. Basic gates of gate, it is set inverter or gate and gate. These are the three basic gates. First we'll see NOT gate. A gate with only one input and the output is complementary output. That is, this is the logic diagram for NOT gate. Only one input. Input is A and output is inverted output. This is the NOT gate. And the truth table is A. If A is 0, output becomes 1. If A is 1, output becomes 0. Is what inverted output. Now coming to OR gate, a gate two or more inputs, but output will be only one. It is high, presented with OR gate logic diagram. This is the logic diagram. Symbol used is plus. And the two inputs A, B is y is equal to A plus y is equal to. Now we choose A inputs combinational 0 1 0 will see out, that is A plus B, or that means if both the inputs are low, then the output will be low, otherwise for all other cases high. Now again also puts out only when all in logic diagram for AND gate is and B, and the output is Y. And the symbol how will represent a dot. Y is equal to A dot B. Table A B 0 0 0 1 1 0 1 1 becomes highest inputs are high, then the output is high. Remaining all cases 0. Only when two inputs are high, 1 1, the output will be. This is about the gates. Universal gates. Any that gate or universals, NAND gate, these universal logic gates. That is or symbol less, okay, and nor means bar. So y is equal to, if we are taking two inputs A plus B whole bar NOR gate expression. And the logic diagram is or bubbled with output. A Y. That is, this bubble is nothing but not. Or plus not. So this is the NOR gate. And A B inverse. That is, for both the inputs are low, the will be NOR gate, both the inputs are low, then the output becomes high, and for remaining all other cases it will be the universality of universality of NOR. That is how this NOR can be taken as NOT gate, can be working as AND gate and OR gate. See this, input A is given for NOR gate, that becomes A bar, inverted output. Okay, so this is working as NOR as NOT. Now we'll see OR. Give 0, okay, that both are 0, so 1. A for both inputs, so it becomes 1. When you give 0, 1, and when you give 1, that means both inputs are high, automatically 0. Okay, how to check? Now we'll see for R. Okay, this is NOR connecting to NOT gate. Already this NOR is working as NOT gate. So draw that single input NOR gate. Now we'll truth table. Now this is equal to A plus B. Okay, we'll consider two inputs A, B. Suppose for example 0, 0. Okay, the output be 1. 1 is given, output is 0. So OR output. Next, when we give these all three cases, this will be again inverted. So we will get 1. So it is working as OR. Now we'll check for AND. A inverted input, B 2 are again connected for no. So now this becomes output y is equal to a dot b. That is checking for and get is if both the inputs are 1, only then y becomes, that is output becomes 1. Okay, we'll check. 0 0, that means output 1 1, for this not 0. Next 0 1, that becomes 1 0. 1 0 for NOR gate, 0. Next 0 1 0, 0 here and here becomes 1. So 0 1, again the output is 0. Now we'll check the last case, that is 1 1. Okay, when you give 1 1, the output for this is 0 0 is inputted, output becomes 1. That means AND gate is satisfied. So this is to be universal gate. We can construct any basic gate by using this NOR gate. Same as NAND gate. NAND gate is also said to be universal gate, and we can construct all the basic gates by using this NAND gate. Same procedure. Okay, you can do. We'll see what is NAND gate. That is y is equal to a dot b whole bar. The symbol is gram. Two input and with bubble. A, B, Y is is equal to A dot B whole bar. Now we'll see the ABY. 0 0 0 1 1 0 1 1. And for actually for AND gate, if both the inputs are high, output will be high. Then AND this becomes 0, and for all other cases the value will be high 1. And you can check the like this using the NAND gate. This is about basic gates and universal gates. Now coming to next gate, exclusive OR gate. This is this gate with 2 or more inputs and output is high only when the number of high inputs is odd. If the high inputs one number, the output high. Otherwise, okay, this is equal to or B. Logic diagram. This is the A and B are the inputs. We'll get Y here. Okay. Now we'll see the truth table. Y. Odd number of ones. Two cases. Here we are having odd number of ones. So we'll get I, and for remaining two cases we'll get low output. And same as exclusive NOR gate. This gate having 2 or and the output is high only when the number of for high even number, reverse. So bubbled with exclusive or is exclusive nor. Here you need to use bubble and the symbol is this with bar. That means y is equal to a exclusive or b bar not. Okay, inverted output. So now the truth a b y 0 0 0 1 1 1. The truth table, that is even high inputs. Even now inputs is, this is the even number of high input. Here there is no ones. So here, this becomes even and this becomes even. So high output and remaining two, the output will be low. This is about basic gates and universal gates. Realize given equation, that is y is equal to AB plus C. AB here and this is O. Take one AND gate and give the input A and output, that is C output or input. So this is realization. You can draw any expression or equation. This realization of how to draw circuit. This can be drawn by using universal gates, that is using NOR and NAND. Now we'll see what are all the laws of Boolean laws of Boolean algebra. In this, here we are operations with and idempotent law, that is x plus, if both the input adding, then will give same as x and x becomes x. Involution law, that is take an input is read by using gain if you inverting the same as out. Next is complementary, that is x is an input with inverted OR gate 1. Do AND operator will get A2 law, that is x, you can do either x plus y, plus is nothing but or same as it is equal to y plus x and y equal to and x. Associate VTU law, that is plus 1 z to y plus, or you can take it as y plus z. Same, x y z is equal to or equal to x into y equal to x into y plus xz. X y z is equal to x plus De Morgan's law. That is x plus y whole is equal to this x bar into this all, same as x bar is equal to x bar or the changing and bar, both these are the Boolean or combinational circuits. Up of logic output of circuit depends at the input at any given time. Do not make memory of this. Now we'll see minterm. What is a minterm? Term of this is a n literal. Here the literal is a variable or its complement. A variable or a and a bar. It is once true form. That means either with or a both at a time. Same as sum of z literals. Product of and sum of n literals. In which each variable exactly once complementary form. But now present this the variables a 0, 3, 4, 5. Minterms are represented with m printed as and this is 0. So inverted value b bar. M1 is represented a bar c. M2 a b a c. M a b bar c bar. A value. So b so a bar, that is b bar. M6 a b bar. 7 is a. The max terms are with cat and m as, but here this 0 is negative logic written a instead of a bar. Equal here and symbol, okay, and here a plus, same as all the values were written a plus c bar. M2 is equal to a plus bar plus c. 3 is written a plus b bar bar. 4 is written as a bar plus c. M5 plus M6 a bar plus b bar and written as a bar plus c bar. This is how to represent. And now SOP. That is sum of products. The expansion, we call it as expansion or of products, or is a Boolean, that is sum of logical products. Logical sum of products is the sum of products. Means the expression, that is the and or circuit. So this is maxterm expansion or this is said to be product of okay. This is logical products of logical sums. Logical product of sums. and this applies or and circuit. Okay, now we will see the circuit. Compute 3 inputs B and the function f is the circuit. Were represented as y is equal to small f of a comma b comma c is equal. Suppose equation or expression b with sum of small letter and 1 to 7. The output will be and for 0 can be written off, that is pi of maxterms m, the remainder, that is 1 2 4 5 and 6. Okay, 2 and p. Well, if the truth test b c f b pos 0 1 2 3 4 5 7. If suppose the truth table is f 3 0 1 2 4 5 are having high value, then f bar becomes low values and high becomes. How to represent this? Minterm is minterm. So written as, okay, output is minterm. A bar B is 0, B 1, so it is A bar, comma, next A B bar, next B bar C, next one A B B C. These are all. Now the expression OP as function of A comma B comma C is equal to of 4 6. The function is A bar C bar B bar plus A plus C. This is the function by the OP 367. Now table again we can max terms. For consider once 0 is A, again 0 B, 0. This is written as A C. Next plus B is A plus B bar C. Now we can POS as function of comma B comma is equal pi capital M. The max 1, so 1 2, and the fun is A plus C bar into dot plus B bar C. This is the, okay. Now we'll incomplete function, nothing but we can use not specified function output for one of its in. For this combination the output becomes don't, either for f or f bar, the incomplete function. One of the example for incomplete function whose at least one of combination presented with truth table is and this output. For example, any combinational input output should be 0. Take this example. 1 don't care, 1 0 don't care, 1. as completely function. We can completely spin. Now write this truth table as SOP. F of a, 3 variable. Small f, where we want 1, 0, 3 as well 7. So 3, don't guess. 1, 6 are the don't guess. That means these can be used 0 or 1. Don't care means you can consider this don't care either 0 according to it. So as sum of okay, the 1, 6. POS, we can write the POS as FEC to pi of capital. Now 0 is existing, that is number 2, 4 and 5. So 2, 4, 5 plus don't care, same. But here we need to represent POS dot, okay, into pi of, okay, because don't care, this is POS, so pi of capital D. Here we are using small d and here you should use small d, and the numbers are same, 1 and 6. Okay, this is how to write the SOP. POS. An example for minimization of SOP expression. Okay, take an example. Minimization SOP expression. Okay, for example, the function is of a, comma b, comma c is equal to sum of one, 2, 5, 6, 7. This is the given expression. Now how will we use this? That is F is equal to, this is written as, okay, 0 means A bar, B bar, C bar plus 1 means A bar, B bar, C plus 2 means A bar, B, C bar, 5, 1, 0, 1. That means A, B bar, C plus 6. A, B, 7. A, B, C. This is the SOP for this given 0, 1, 2, 5, 6, 7. 0, 1, 2, 5, 6. Okay. Now, we should take a common, okay, that is from this terms, we can take A bar, C bar common. So, C bar plus C. C bar plus C using complementary law, okay, C bar plus C becomes 1. Name this and this, take B, C bar common. So, write A bar plus A becomes 1. From these two, take A comma C, B bar plus C, B, this expression is bar plus B, C bar plus AC. This is to minimize the given SOP. As we can minimize POS, minimum product of some expression. For example, the given function is that pi of 5, 7. This is as B 1, okay, representing with the 5 as plus B plus 1, 1 and 6. A plus B bar plus 14. 1, 1, 0. 1 means A bar plus B bar plus D to 2. 2 means 1. So, A plus B plus D 2 into 10 means A 0, 1, 0. A bar 1 is represented A bar plus C bar. This is how to POS function. Now, from this again, a common. Okay, from this 2, we can take A bar, B bar plus this 2 plus D bar common. So C in that becomes using that is A y bar into plus y becomes x. That means here x is not changing to, so this becomes x. This if you take A plus B bar plus C bar, C is changed to C bar. So this becomes B bar plus D bar. Next consider this and okay. Points. See here changing to, so remaining B bar plus is remaining. When you come to remaining term, changing plus C. Okay. Again by these two terms, that is changing B bar to B and C bar plus D. C bar. Finally, the minimized expression. For POS. K-map. It is one of the to simplify the. This method is faster and easier to other than other simplification methods. So we are using this. This is simple, faster compared to methods. Using now will simplify. Yes, again we are having different variable K-map specific of for every of values independent. Here to map well K-map. Now we'll see well K-map. In this, the number in where become two variable, that is 4 cells. That means this is cells. And the represent A. One is complement A bar and another is same as B bar. B. Now here the cell numbers, that is depending on the values, that is A, that means 0 0. So this cell number is 0. A bar 0 1 is 1 0. This is A 1, B bar 0. 1 0 means a cell number 2. Next A, B, both are 1 values, 1 3. These are all the cell number. Now for example, given that is y is equal to A is equal to summation m of 2, 3. For example, given example for 3, 2 term and third term, so plus in A bar A, B bar B. Now, where is 2? This is the cell number 2. And next, this is the cell number 3. And for remaining cell number 0. Okay, this is a K map. Now we'll see 3 variable K map. 3 variables means you can take one variable one side and 2 variables other side, or 2 variables one side and one variable the other side. Both you can. This is called as row wise or anyone. Okay. So this side two variable combination. A bar B bar, A bar B, A B, A B bar. This side only one variable C bar and C. Same as when you come to this is a column. So you need to write variable at one side A bar A and remaining two variables B C on the other side. B bar C bar, B bar C, B C, B C bar. Now the set you need to value A B C and 0 0 1 2 3 comes this and 5 6 7. These are all the cell numbers. Same as when coming to here, this becomes 0, 1. Leave one column and go to here. This becomes 2. If you have any doubts, 1, 0. So this becomes 2. Next, 0, 1, 1. So this becomes 3. 4, 5. Again leave this 6 and 7. This is the cell numbering. And for example, if you can take any function S you can place the var 3 variable map. For a function y is equal to a comma b comma c is equal to summation 2 comma sample taken. That means sum becomes remaining all values or so 2 where is 2 and 6. Okay, remaining all and when you y same again 2, okay, 6, 7 values 0. Now 4 variable k map. Same as this 4 variable k map is that is you can write 2 variables on the side. Taking a b this side, a bar b bar, a bar b, a b bar, and this side four variables so c d c bar d c d c d bar. These are all the remaining 2 variables on the other side. Okay, and we can take one example. the function see here the cell numbering before going to exam 0. Okay. Next leave 1, go for this 2, next 4, 5, leave 6, 7. Now leave one row and name it as 7, 8, 9, 10. The 11, 12, 13, 14. Okay. Now is equal to f of a, b, c, d, 4 variables. Summation m of given example, that is we can take any number 1, 6, 7. That means 1, the value as well 6 and 7. Remaining all this will be 0 values. Now coming to minimization of a given expression, that is SOP, or you can take POS also, you can minimize by using K-map. Okay, here again we are having how to group the adjacent variables. Okay, here how to group those? We are having this pair, quad, these two groups. Okay, pair, pair means we'll check for adjacent. Suppose if a one value check for adjacent one more one. Now pair eliminates one variable. Pairing, we can eliminate one variable. Okay, pair means check for two. It eliminates quad. Coming to quad, adjacent for ones, adjacent ones for, okay, two variable, same group for adjacent ones variable considering that is 1 f of b equal to summation 0 1 4 6 6 consider 13. Couple will see how to do this group is pair and octet map variable consider. Place the term 0 means term is term 1 so 1 2 4 5 6 7 okay 0 2 4 7 8 is so place 0 9 place 1 okay 10 there is no 10 so place 0 11 position 11 term cell number 1 11 12 12 12 13 to again is there 0 so we'll do octet check for one adjacent so make a of page first we need to search for a maximum way grouping. So actually this is called roller value. So this so instead of next one hit at octet elements need to these all group if any grouping which eliminates you can group that okay. Remaining and one this is again rolling by using this one and this one become but that if we roll these two with the news a so it will see if possibility of any other octet then it is okay no possibility so we are doing this as a quad okay so all the ones work how to make a grouping pair quad octet first check for point not existing for a quad if again it is not possible go for pair if this pair is not possible we will as alone and write the minimization. Now, y is equal to minimized expression. See here, the here the variable which is changing is eliminated. Yes. Okay. B bar is changing to B. So it is eliminated. Only we can consider A. Okay. This side, all the two variables are changing. See here, C bar is changing to C as well D is changing to D bar. Okay, so all this for combination, that is 4 cell. So changing, so eliminated. So only A bar. Next, coming to this quad. Okay. B is constant, A is changing. So B, and from this end and this end, check the is variable changing bar is constant. So this quad eliminated 2 variables. Here 3 variables. Now check these two. This and this B bar A. So consider and changing to eliminate C. Only D is constant. Finalized expression of SOP by using K-map. While doing this grouping, we need three points. That is, first one is rolling. That means you can roll this side, this side, this side as well. If this, for example, okay, roll like this, thus we take this is, and then overlapping. We have that is here overlapping. Because of these and there is no of hearing, so this is said to be overlapping. If this is already done a grouping, then no need to octet. Okay, this is nothing but wrapping. Third one is eliminating redundant group. That means, for example, here one more existing, that is you can do like this and form it as a quad. Already this one and this one is grouped quad as well, and same as, and this one is already, one is grouped with quad and this one is grouped with octet. That means this is redundant. So no need to make again one more quad. One time doing is enough. This is what thing. These are the three things doing the group. Using this K-map, some of the limitations, that is, number of variables go on increasing, the simplifies again it increases. This is one of the limitation. See one more example to solve P1. Okay, take is equal for A, B, 5, 0, 2, 3, 12, 14, 15. With don't care, that is don't care, 5, 11. Because what we need to do is, don't care means wherever it is, you can play it. Actually, pi, that is POS. When you come to SOP, place once because we are once, but when POS, okay, we'll see the first map. Okay, here as it is A bar, we need to place next C. Okay, same plus V. Okay, and here D bar, C bar, D bar, this here where there inside you need to place zeros. Okay, so place 0 and leave at next. This is 0, 3, 4, 6, no 6, 7, no, it is there, 0, 9, no, no, 12 is there, okay, place 0, no 13, 14 place 0 and 15 place 0. Okay, 14, 15. This is how to place that is POS, pi of. Okay, next into this is here 1, 4, 5, 7. Okay, don't know 6, 8, 9, 10, 11 don't. Okay, remaining you just place once. POS groups, please you need zeros. If a zeros on grouping, actually this and there is no zero. Okay, but consider as 0 and you can group it. But there is a possibility grouping these as a quad. We are considering this, don't care as 0, grouping this. Okay, next. Coming to here, there is 2 zeros again here. So, again you consider this and put as a, because instead of if you do quad 2 variables, more simplified expression. Next again, here don't care is there but 0 is not existing. So there is no of a, so pair. This expression y. See here this 4 columns. So 2 variables will be eliminated. These 2 will be constant. So C plus D. Here eliminate only A plus B. Constant. To this A bar plus B bar both will plus from, okay, changing and bar will be considered. This is the final POS minimized expression. Now we will solve one of the problem by using K-map, that is P is minimize. Now we'll K-map. Set to 15 to one side and other 2 variables side. A bar B bar, A bar B, AB as it is. Next A B bar is the one side and other side C bar D bar, C CD CD bar. Now we will place the given terms in the cell numbers. Space 0, 3, 0. This is the place next to, because 2 is 0. 4 is not place. So place this is 1. Place 1 and number 8 given 9. So place 10, 0 given, place 1. 12 is third, so 0. Leave 1, 14, place 1 and 15 is 0. Now we will solve this SOP using K. The first point we need to remember possibility of grouping, that is octet. Is there any octet possible here? It is not possible. Go for a yes, one can make. So make it as a quad. And check the other possibilities if there exists any quad. No, there is no other quad possibility for pairing. These two we can pair. As well, these two one pair adjacent. Okay. Now see this one, but by using rows paired by using rolling with upside. Same as the left, then B is 1. Okay. Minimize using K-map expression. Before going to expression, one here this one already another, so no, this becomes redundancy gate overlapping to get the pairing. That will simplification S bar bar because one row. Consider A bar B bar and from is changing, that means eliminate D and consider bar plus quad. So these two rows, from these two rows, so eliminated R is considered. From these two columns, that is C is changing, and the next coming to these two. Okay, CD is plus C and A bar and the row is B bar is constant, and so bar. That B A is only the and only one column. We need to is 2. A one row the AB as 2 constant C is changing. So take D. This is the find S1. And here you can get simplifies the example. If you group as a pan, no two pairs. So remove this. By this we'll get A bar B. Okay. This C is constant. A bar B and C. This term will be coming instead of BC. You can that means expression is bar C plus ABC plus ABD bar. Both are correct. Use pairing or like this. If you do this will be the expression. If you do this will minimize expression. Okay. This is how simplify, that is minimize using K-map. Okay. Now we'll see for the question. Yes. Here 4 variables clicking A bar in Y circuit and for S. Take the A bar. Again not get as for all the input variables. Now in the circuit. Okay. A bar, B bar, C bar and connect A bar, B bar, well, C bar, this C bar, and gate. Next, A bar D. Take one input, D another input, two input and gate. Next, one input is C. Okay, from C. Next, another input is D. Input is B bar. So, three input and gate. Next, B, C, D bar. So, this is the B. C, D bar. Connect with D bar, A, D and D. Now, connect all the terms for our gate. Is the minimized X. This is how to the circuit. Helpful, full half adder, subtractor, half sum, binary, gray, all in your lab experiments. We'll solve one more problem, that is minimize using K-map. Don't care. See here, this is the SOP given. Okay, function f of A is equal to function m of 2 and 10 12 plus don't care 11 15. Now we'll solve this problem using take two way A and C D and place the numberings. 3. Okay, now 2 is given. So place 0, 1, 2, 3, 1. Cell number 5, that is 4, 5, 1, 6, 7, 1. It is not given. 9, not given. 10. So given 1. 11 is not, it is in, so write don't care with X. Cross. Next 12, 10. So 13, 14 is present. So again in 15. Okay, remaining answer 0. Now using K-map. See here, by use care is nothing but you can place either 0 according to our requirement. This don't. Okay, you can do quad by using third. Okay, and more possibility do here. Okay, considering there can be considered and yes as a quad, but possibility of pairing is existing. If you do pairing this, no take the, because unnecessary care grouping in circuit. So yeah, okay. Actually possibility maximum is quad is, but here it is not. So consider as one. Making this quad, one more exists because you can possibility. So pair with one. This one is known in quad. If you do quad, this becomes trivial. No need to do that. See here, okay, this one is you check for rolling, okay, not possible, or adjacent values, this, no, there is no adjacent ones here, as well is equal as it is, as the is minimized expression is equal, okay, from a bar b, d is constant, a bar b into d, single it is b c bar plus is it, so b is c bar, and from, okay, c is this expression for this set. Now minimize OS using cases, so term given you need 0 instead. For SOP we are placing 1, POS you should place 0. Same procedure. Okay, 0. So 0 you need to place 0. 1, 2, 4, 5, 6. So here place 7, place 0 is because 6, 7, 8 existing. 9, 10, 11, 12. Again 12 is there, place 0. 13 is, 14 is there, place 0. Next 15 is there, place 0. Okay. Remaining and all you need to consider as 1. But use pi of the, you should group zeros here. So now it again max v is again 1. Okay, pair with this tone. We are using rolling method. Here 0 with rolling 0 and this with quad, so no need to as a this, so F2 minus Rex C consider unit, but here for expression, so we should write plus, and this side all were changing as well. D in next is B bar constant, C bar. Next I there C bar and A bar means under B. Here C bar D bar means how write was expression. You should then SOP place 0 right, that is if suppose you should place, if it is A bar you should place, this is what the procedure. One more example for POS, that is pi m of, okay, with don't care. Okay, now we'll solve this by using K map for don't care. Okay, draw the K map, place the variables. Okay, what are all the terms given, that is z 8, 12, 14, 15. So z place 0, 1 not given, 2 place 0, place 0, 4, 5, 6, 7, 8 given, and 10 not given, 12 that is given, 0, 13 given, 14, 15 given, place 0. Okay, now see the don't cares. 1, yes, don't care. 1, next 4, 1, 2, 3, 4, don't care. 5, don't, okay, 7, 10, 11, this is don't care, remain, you place 1. So we need to group the zeros. Your group, you can consider that as grouping key, that as consider it as this for quad, so it has end. Okay, quad is exist. Okay, thing do to eliminate variables possibilities in don't care row. Okay, there is of one possibility to the x from O and D. So leave A bar B bar. So write A K bar. So this okay. E is changing C A B means C bar. This is the expression used for as we discuss use app simplification. The number of the synthesis is increased. So avoid this going for the method. See there how to simplify that. This tables is written time implication and essentiations. The expression or at least that all the term true prime exact implicants declare avoid duplication. This is given by using method simplifier programmed digital. Proceed with one example. So P is of AD is equal to 1, 5, 7, 8, 9 using key method. Solving the steps. Arrange the given terms. That means we need to write minterms for this. Okay. Before I'll see the process is ascending order. Minterms should returning order as and based on what's first I'm group with number of ones and writing the minterms. That is the stage 0. That means this one group. Next 1 0 0 0 1. Again will be one number of now 5 5 0 1 1 0 2 1. So as the next 0 0 2 as in 7 means 0 1. That means so it as a group 1 1. The where only 1 9 means that means 2 is here 0 where 2 1 here only 1 10 1 0 the 0 place as 1 to 14 means once. Now write in terms I have as this is 5 6 9 10 7 and this is okay grouping stage. Here and every group other group is in bit position pair of interm. We need to sim that is hyphen division. It means change that we need to minus and keep remaining bits as it is. Now I will show how is it. Here we are comparing this all in the compared with 0. So all 3 bits or and last 0 is 1. Make it keep first 3 bits as it is and it fourth position. So play same in with so pair it again at the position 0 0 and it next for 0 8 1 0 completed. Comparison other group. Now with here 1 here changing to 1 the third position is 1 comma 5 0 is changing next again the next step changing 1 again to 2 change 0 is store we cannot group 1 taken place need to group next this 9 possible 0 is change 1 comma 9 is again then possible 1 second change 3 changes needs compare all this mean okay is changing to 1 1 is changing so leave it change next not changing 1 not changing here it is changing here it is not changing so 0 hyphen 1 with a 9 sorry not 2 9 it is 0 1 and 1 is changing leave it coming to and 0 is 0 yes possible group 10 2 that is first bit is changing hyphen 1 all groups were compares group constant is changes constant so it's possible 5 comma 7 1 1 next 5 that is changing not possible so compare it is changing and remaining So 0, 1, 1. That is 6, 1. Next 40, it is possible. So 3 bits, a constant, and this bit is changing. So 6, 4, hyphen 1, 1, next 7. Constant, this is not possible. Living with 10 and also changing. So not 10 bit not changing. Fourth bit not changing. So it is 4, it is same 1, 0. So this is completed. We are going for stage. Compare group possible. Okay. Fun existing. We can this for hyphens exist. Check it's 0, 0. Okay, 1 bit is 1, 8, 9 possible. That first bit value is changed. 0, 0 hyphen. Next any match, no, there is no other hyphen at the end. So 0, 1 is completed. Next 0, 2 for the sec hyphen it is there. Okay, 0 is changing. That means hyphen 0 hyphen 0, 0 2 8 10 0 2 10. Next 8 the thing position is it, and 2 0 9 0 8 with 1 hyphen 0 0 constant place. Okay, one more position yes with a 2 10. So 8 10 already exists. No need again group. The time is n. Okay, this group hyphen the done it is. 0 is changing. Hyphen again 0 is changing. Grouping is like this. Hyphen in the fully one possible. Hyphen 0 is changing to 0. Leave go for 2 comes. That in the position. Seconds. Okay, this changing to hyphen is constant 1. So this is possible. 2 16 6 14 2 changing hyphen again and 1 0. Okay. That one hyphen here. Position changing constant. That means hyphen 1 0. This is same hyphen 1 0. Same. So no need to again group this. So leave as it is. Okay. So these are the last grouping terms at the stage 3. Now we'll see the prime implicants chart. The prime implicant chart is rows and columns. In the row, we should write here row, we should write minterms. So these are all the prime implicants. Now we'll write this prime implicants as a row, as one row. That is, see here, this is the 0, 1, 8, 9. Okay. Next one is 0, 2, 8, 10. Next one is, see here, 0, 8, 1, 9. It is repeated. Okay. So no need to write again. Now 2, 6, 10, 14. These are the prime implicants. So we have written in the row wise. And at the second stage, 1, 5 is not covered. Okay. And 1, 9 is also 1, 9 is covered. Okay. 1, 5 is not covered as well, not covered, and 6, 7 is not, and we are the word, that is, see here, more changes. Okay, so this is not covered. The grouping minterm to contain essential prime implicant chart, that is 1, 5, 5, 7, 6, 7. Now we'll write what are all the terms, that is term is A, B, C. that is C bar, B bar, 0, 0. Next, A, B, C. That means A bar, C bar. Sorry, A, B, C, D. I'll write this here. Variables. First one is okay. Next one. This is A, B, C, D. So B and D. So B bar, D bar. Next, coming to this is C. 0 means D bar. C, D bar. Next, for this, what is the minterm is A0, A bar, D. And for this, A bar, B, D. The next is B, wise. Write all the given at the side. 0, 5, 6, 9, 10. Now, place the cell being that event. Prime implicant word place here and position if prime in place 1 or okay. We'll write that 1 is 0 cross or 1 cross. Next 0, 0, 2, 8, 2, 6, 10, 14. One and 5. 5 and 7. 6. Now by observing the each can find out essential that is minterms covered in this table covered minterm that is second. Okay, we'll check that the minterm if it is covered only one time. That means this 0 minterm is covered 2 times. So next one is covered 2 times. No, not required. And 2, it is not prime implicant. Next, this is not. And 7 2 times not. 8 2 times 1. 9, only 9 is covered one time. So this becomes essential prime implicant. That means B bar, C bar. Next, this is 2 times. This is not essential prime implicant. 14. Yes, again 14. 14, that means 14 is in here. So when writing the simplified expression that is F, these two are essential. That means this should definitely include in your minterm. Okay. So these are the two essential prime implicants. Okay. Because these are covered only one time. All covered 2 times. So these two are essential prime implicants. Next. Reduce the prime implicant table by removing the row of each essential prime implicant and the column corresponding to the minimum terms that are covered in that essential prime implicant. That means, see, this is the essential prime implicant. as a row. Which row all covered? Remove that. Yes, that's it. And again, this is the essential prime implicant. Make a row, and which row all? The prime implicants covering this. All this. The remaining is 5 and 7. Only these two. That is, this is the 5 and this is 7. So consider this A bar BD. This is the simplified expression mcclusky method. Of incompletely specified, that is, given incompletely specified function, proper assignment to the don't care terms is necessary in order to obtain a minimum form of a function. Okay, that means wherever there is a don't care, we need to place with proper value, where b 0. This is what specified function. Now we'll sample, that is SOP is given, that is f of ABCD is equal to summation of 2, 3, 7, 13 plus don't 15. mcclusky method. Now the same procedure to take the here. So first stage 1, the terms, the number of ones to group. Okay, now 2. Actually we need to consider don't go 1 0 0 1, next 2 0 1 0. 3 is next group 0 1 1, 11 is 0 1 2 9 the second 1 0 0 1, 10 is 8 plus 2, this group 8 0 1 0, 10, 11 means next group, that is 8 9 10 11. Next 13 means 1 1 0 1, 13. Next last one is don't care, 15 1 1 1 1. This is the first stage. First stage is completed by using mcclusky. Next say stage 2. Now go on, compare the two group minterms and pair. Okay, if there only one change, 0 0 hyphen 1 1 comma 3 0 0 hyphen 1. Okay, next 0 0 1, that means hyphen 0 0 1, that is 1 comma 9. Next it won't change because 1 is changing, 0 is changing. Okay, we cannot pair. Next 2, that is 0 0 0 hyphen 0 0 0 hyphen with not 0 is and here changes we cannot pair. So next 2 with 10. Yes, it is hyphen 0 1 0. 2 with 10 hyphen 0 1 0. So completed. Now next coming to this group comparison with this group, that is first is possible, that is 3 comma 7, that means 0 hyphen 1 1. Next 3 with 11 is possible, 3 with 11 hyphen 0 1 1. Next 3 with 13 is not possible, okay, leave. Next 7 not possible because 3 changes. 9 with 11 not possible. Yes, possible. 1 0 hyphen 1. 1 0 hyphen 1, that is 9 with 11. Next 9 with 13, 1 hyphen 0 1. Okay, because 1 constant is changing, 0 1 constant. So 9. Next change not possible. 10 with 11. 1 0 1 is changing. 10 with 11. 1 0 1 hyphen 10 with constant changing. So second group comparison is completed. Now with this, okay, that is hyphen 3 ones hyphen visible hyphens. Next 1 1 11 with 15. Next 13 with 15 is possible because 1 1 hyphen 1. Okay, comparison is completed. Next stage this group with this group, okay, that is hyphen in the second position, only 1. Okay, hyphen in the second position, hyphen 1 0 is possible, hyphen 0 hyphen 1 hyphen 0 hyphen 1 1 3 and 11 1 3 9 11 hyphen yes 0 hyphen 1, that means 1 and 311 same, 1 9 311 is same, so no need again same repeating, only once is enough. Next compare this 2, that is last hyphen only one possibility, but 0 is changing, okay, and here 0 is changing, not possible, so leave it. Next come 2 10, okay, 2 10, that means 2 10 is hyphen starting 311. Yes, 0 constant, 1 constant, it is changing 2 10 3 11, that means 2 3 10 11, okay, that is hyphen 0 hyphen 1 hyphen 0 hyphen 0 1. Okay. Next 2, that is starting, okay, completed 10. So is completed. This group with this group. We'll check the second place. 1 is changing. Hyphen 1 visible. Hyphen 7, 11, 15. Hyphen. Okay, next 3, 11. That is starting hyphen completed. Okay, now position hyphen, yes, here it is. Third position hyphen, yes, possible, because one constant hyphen 1 hyphen 1. Okay, that means 315 and 9 11 315. Okay, in sequence. Next is hyphen in the second position. This is, I think, already completed. 3 11 15 9 3 11. Next 10 11, that is last hyphen. There is no last hyphen, so grouping is completed. Now we'll see the prime implicant chart. Okay, prime chart. As we know, write the prime implicants as a row and write the min. Okay, so prime implicants, that is, this is 1 3 9 11. Okay, 2 3 10 11. Next 3 7 3 9 11 15. Now this 2 17. Now this prime implicant covers here was 1 need to consider either 1 plus 1 9 11. Next 3, here no problem. Next 7 10, leave it. 11, don't care. This is 13. 3 9 13 13. Okay, we'll check, that is, how many times these prime implicants were covered in the minterm. See, this is only one time. Two and 7 and 13 only, and all 1 means for the essential prime implicant. So to go next procedure. Okay, so prime implicant, or these 3 are the essential prime implicants. Only one is left, so this completes the final minimized SOP. That is, what is this value? That is B bar C plus, this is T AD. This is finalized SOP. Incomplete completely specified function that is nothing but don't care. Petrix method. It is also used to minimize the SOP. Actually, in quine mcclusky method, okay, there may be two minimum in by petrix method. It is a fine solution. The prime okay procedure is mcclusky method. That is, this is the SOP, that is 000 and 2 1 6 1 now. Okay, this is stage 1. Stage 2 groups. If there exists only one bit position changing, then pair it. Okay, yes, 0, 1, 0, 1, only one diff, 0, 0, hyphen. Okay, next 0, 2, that is 0, hyphen 0. Completed first group. Next 0, yes, 1 with 5. It will be group that is, it is changing hyphen 0, 1. Next 1 with 6, not possible because 1 is changing to not possible. Now compare with the 2. That is 2 is not possible because 0 is changing as 1 and 1 is changing 2 changes. Let's compare, this is possible. So this 2, that is first position, next position 1, 0. Next these 2, 5 with 7, yes, it is possible. 1 constant, next change constant. Next 6 with possible, 1, 1 hyphen because it is changing. Now these are the prime implicants. Okay, from this we are constructing the prime and finding the essential prime implicants using mcclusky method, right? But here we are writing the prime implicant chart. That is prime implicants with main terms, okay. Prime implicants, these are all the prime implicants. Name it as P1, P2, P3, P4, P5, P6. And what is P1? Zero combined with 1 pairing. So this is when you take A, B, C variables. Now A bar, B bar. Next P2 is 0, A bar, C bar. 3, 0, sorry, 1, that is bar C. Next 2 with 6, B, C bar. Five A, C. 6 with 7, A, B. Okay. In terms, that is 0, 2, 5, 7. First, okay, place 0, next one, so 0, 2, next 1, 5, so 1, 5, next 2, 6, 2 with, next 5, 7, 5 with 7, 6, 7. Check. Actually, 2, okay, 1 is covered 2 times. All were covered 2. So, essential implicant. If you want, you check this. Yes. Here, procedure that is. Now you group the, that is P1, 2. These two were covered with minterm 0. Finally, represent petrix method with P, capital 1, 2. Next, P1 with P3 because it is covering P1. So, right here and plus P2 with P4. P2, P4. Next, P3, 5, P, 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 P6, P5, P5. Now, P5 that is use become P1 plus 2, P2 plus 2 coming P, P6 with P4, P4 and P1 with 2, P6. Next, this two P2, P plus P2, P2, P, P6. Right? 1 is becomes P6 in P5, P3, P6. Now, process P1, P5, P2, P6, P2, P5, P3, P4. Again, that is P1, P2, P3, 6 again repeated. So, no need to write. Only one time is enough. P3, P6 plus P2 is repeat only one time. 4 here P P3 write 1, P6 repeat type. X, Y, X eliminate the terms. Okay, now whether it is 4, 5, any 1, 4, 5, 5 term, this, now we'll 2, 3 with 4. This 6 will be a 4. So like this we'll get 2 P2, P3, P6 with 2, 5, 5 removing. Next again 2, 3, 6 with 6. So finally only one P2 will be 2, 3, 6 will be distinct. These 4 terms. That is final P1, P plus 1, 6, P4, P5, P4, order, P6, finally 1, 2, 3, 6. Final minimize expression will get the minimum number of prime implicants. Number here, this is the minimum number, and again this is the minimum number. That is P1, P4, 5, 2. Now be the SOP. 4, no 1, 1, 5. Okay, where we'll check that A bar here ring bar, it is plus B bar plus next 5. Here it is covering 5. Okay, so CSE expression or that means equal to bar C bar plus B bar plus 6 or A, or again you can consider that is 6. 6 is covering in 2 terms. So take one for one SOP and other, that is BC bar, or for other SOP. These are all the two solutions. This is the minimized SOP by using. We will discuss simplify the given SOP, or this is given SOP. That is, the other technique is map entered variable, or it is entered variable map to increase the effective size of K-map. It means it allows map to handle large number of variables. This is how this is done is by writing in, see this, and this is the taken NEV entry use outcomes of this input. Okay, now we'll see how it is we map. Suppose for example, if the output is 0 and input is this combination, both are 0, we need to enter 0. If both output is 1, enter
1. Both output and input both are 0 as well 1. That means input output same. So enter MEV. MEV is nothing but input. Input is 0, output is 1. Input is 1, output is 0. That means inverted. So write this MEV bar. That means input inverted value bar. Now when you consider care, that means you can place any value. The MEV becomes don't care. One output is 0 and one output. You can replace this don't care with 0. So output becomes 0. Same as 0 don't care 0. 1 don't care. So don't care is replaced with 1. So output becomes 1. 1 don't care. So don't care is replaced with 1. So you should enter variable 1. This is how to enter the MEV entry by using the rules. Now we'll see one of the example is given SOP is f of a b c is equal to summation m of 0 1 2 5. This is the given SOP. Okay, this terms there will get the output 1. Need to write for the 3 combinations 1 2 3 4 5 6 7. What SOP given? 2 0 1 1 for 2 output 3 0. Again it is 6 it's 7. Now MEV. Now considering put C the output. Okay, 1 is here both outputs, so 1 0 the output and output are inverted. So MEV means here the MEV is C, make it C and output, that means P. Enter 0. We can write 0. Writing the MEV AB on AB is into C. Will get 2 variable combination 0 0 1 1. Output 1 3 C bar C and 0. For this now we'll draw this is the K map variable A one side, B bar B other, you play 1 C 0. This is how to solve, that is minimize the steps to this case. First place C bar as, so from this you need to place zeros where there is a C and C bar zeros, and here write as it is, and 1 write as it is. Okay, 1 is written as it is, placed with 0. Now 1 is A bar, B bar. This is okay. So A, B bar. This is 1. Now next procedure, step 2. What we need to do is need to consider automatically 1, 0 and becomes 1. Whenever there is a 1, you need to place don't care. That is 1 is equal to don't care. Here in this first case, C bar is equal to 0. In the second case, C is equal to 0, C bar becomes 1 and wherever there is a 1, place. Okay. Now here it is a 1, so placing don't care. C, here it is C, placing 0 where C and C bar in this location cell, placing 1 and 0. In the first step, what we have did is C bar is equal to 0. So here it is C. So placing 0, 0 and as it is 1 and 0 placed. From this, if you do grouping, it is a single one. So we will get A bar, B bar. Now we'll see that it is to 0 and replace 1 with, so here okay 0, then 1 is this and a pair. Now write the SOP2 as, okay, for this when you do this pairing will be the expression is changing, only A bar is constant. But we have written in occurrence of C, here this C is 1, so this becomes C. C bar. Here it is C bar. We are placing the C bar as 1. So this is the occurrence of C bar. We get A bar becomes A bar, C bar. Next, same as third step. Again, we'll write the K map. A bar A, B bar B. Now, what will there is a 1, replace with 1 care. Okay. And reverse case. Here C is replaced with 0. This replace the 1. C bar is 0. C bar becomes 0. Replace with the C 1. C bar with 0. Is this 0? To the pairing, we'll get SOP. This is the pairing. So now we'll get T. A is changing. So only B terms of C will get bar of. We'll consider all these 3 and we'll write the minimize, that is 2 becomes B bar plus A bar C bar plus A bar plus B bar. First SOP A bar B bar and A bar C bar, and next SOP B bar C. This is the final minimized expression F. One more example, that is 4 variable SOP. Summation M of 2, 3, 7, 6, 7, 9, 10, 13, 14. This is the given SOP where there is a output in this term. You should write 1. Okay. With the 4 combinational values 0, 0, 0, 0, 1, 3, 4, 6, 7, 8, 9, 11, 12, 14, 15 to 15, 4 variable combinational values. Now we'll write the output. 2, 3. Well, no 0, 1, 0, 2 is given, 3 is given, 6, 8, 9 is given, so 1, 12, 10, 1, 11, 0, 13 is given, so 1, 14 is given, 1, 15 is not given, 0. This is the output by using this SOP. Enter the MEV. See, these two outputs 0, so enter value 0. 2 output 1, so enter 1. Again 2 enter 0. 2 values 1, enter 1. Input as well output both are same, so enter MEV. MEV is the D. Now input 0, output is 1, input put 0, inverted values. So MEV bar, that means input is D, 0, 0. So input output same. So D. 0, 1, 1, 0. Enter D bar. Now we'll write this as a variable map. ABC 3 variables, all the 7 combinations. That is cell number 0, 1, 2, 3, 4, 5, 6, 7. All in K-map in the previous video. Now A variable one side and BC variables the other outputs in the cell numbers according to the cell number. So 1 cell number 0, 1 cell number 4, D 5, this is a 6, D 7, D. Now according to the 3 steps, MEV, that is the first step. Place where the D bar with zeros. Here These C bar all becomes zeros. As it is this value 0, 1, 1, 0, 0. Make a group. This is a pair. So, the variable is changing. Eliminate C constant here. A bar is now becomes A bar C, but the occurrence of D, there is no D to consider D. First S was A. The next in this is 1 pairs equal to 1. D bar here the ones replace with where there is these two location numbers 1 typically next to 2 D bars 0. Again now okay only once these don't case were not used. These that is B is changing C brent bar A from this C bar is the occurrence of D. D is 1. We are considering D is 1 occurrence of this is the B to A C bar D. That is 0 1 occurrence D bar. So expression and we'll write as it is wherever don't care there is a replace with D is 1. So use K map this considering and quad equals as well here. So eliminate B. Remain. This is the set. This is D. So write a D bar. This becomes SOP3. Now as F is equal to A bar C bar D plus bar. This is the way how to minimize the given SOP using MEV or this is. Please do subscribe my video.
Myself Ushashri, now about Module 2 Analog Electronics. First top, what is an system where change continuously? An analog signal whose amplitude can take any value given limits. Signal that is analog signal. Now coming to phonics, it is a fixed involved is a signal who can have discrete defined limit. This digital rate on to clock period used as a time by from calculated cycle duty cycle distance between level time level time and low level time is time is off. This total ought to be this is on off time is a period from calculate the frequency time period. Now duty related duty cycle H total duty cycle low is divided total. This is how to calculate the duty cycle. Now digital circuit, one or signals but an output signal is called a gate. It is having you can give any number of inputs but output is logic circuit is a ditching kind of circuit that of the base universe. We'll see basic gates, not gate or gate and gate. These are the three basic gates. First we'll see NOT gate. A gate with only one input and the output is complementary output. This is the logic diagram for NOT gate. Only one input. Input is A and output is inverted output. This is the NOT gate. And the truth table is A. If A is 0, Y output becomes 1. Is 1, 0. Inverted output. Now coming to OR gate, a gate with 2 or more input output only 1 represented with diagram. This is the logic diagram and the symbol used is plus. And the two inputs A, B and the output is Y. So Y is represented as Y is equal to A plus B. Y is equal to A plus B. Now we'll see the truth table, that is A, B are the inputs. Combinational bit values 0, 0, 0, 1, 1, 0, 1, 1. For this, we'll see what is Y. That is A plus B. Or that means if both the inputs are low, then the output will be low. Otherwise, for all other cases, it will be high. 1. The AND gate. Again, this gate is also consisting of 2 or more inputs and output is high only when all inputs are high. Logic diagram. Gate is A and B and the output is Y. And the symbol how will represent is dot. Y is equal to A dot B. Truth table A, B 0, 0, 0, 1, 1, 0, 1, 1. When the output becomes high is when all the in high, then the output. So, remaining all cases 0. Only when I 1, 1, the output will be 1. This is about the basic gates. Now we'll see universal gates. Logic function, that is logic circuit, can be implemented using and of such gates are said to be universal logic gates. These are NAND gate and NOR gate. These two are said to be universal logic gates. The representation plus and bar. So, 2 in B or no. X diagram for this or bubbled with output B and Y. That is, this bubble is nothing but not. So, this is the NOR gate. And truth table A, B OR gate inverse. That is, for OR gate, if both the inputs are low, the output will be low. Coming to NOR gate, if both the inputs are low, then the output becomes high, and for remaining all other cases, it will be low. Now we'll see the universality of universality of NOR. How can this NOT gate can be AND gate? Say this, input A is given for NOR becomes A bar, inverted output. So this is NOR as NOT. Now we'll see OR. When you give 0, okay, one input, that or the A, so it becomes 1. When you give 0, 1, and when you give 1, that means both inputs are high, automatically the output is 0. Okay, how to check the values. Now we'll see for OR. Okay, this is NOR connecting to NOT gate. Already this NOR is working as NOT gate. So draw that single input. Now we'll check the truth table. Now this Y output is equal to A plus B. Okay, we'll consider two inputs A, B. Suppose for example 0, 0. Okay, the output becomes 1. 1 is given. The reversed output is 0. So OR output. When we give these all three cases, this will be again inverted. So we'll get 1. So it is working as OR. Now we'll check for AND. A inverted input, these two are again inverted for NOR gate. Comes output Y is equal to B. That is checking for AND gate. What is the AND gate? Is if both the inputs are 1, only then Y becomes, that is output becomes 1. Okay, we'll check. 0, 0 output here 1. 1, 1 means for this NOR 0. Next 0, 1, that 1, 0 for NOR gate. Next 0, 1, 0 here and here 0 becomes, so 0, 1, the output is 0. The last case, that is 1, 1. Okay, when 1, the 0, 0, 0 is input, output becomes 1. That means AND gate is satisfied. So this is said to be universal gate. We can construct basic gate by using this NOR gate. NAND gate. NAND gate be construct all the basic gates NAND gate. Same. Okay, you can. We'll see what is that is equal to A dot B whole bar. The symbol is that is logic to inputs and with bubble. A, B, Y is equal to A dot B whole bar. The truth A, Y. 0, 0, 0, 1, 1, 0, 1, 1. NAND gate. That is for actually for AND gate, if high, output will be high. The reverse case is NAND. So this becomes 0, and for all other cases the value will be high, 1. And you can check the universality like this using the NAND gate. This is about gates and universal. Coming to next gate, exclusive OR gate. This is this with two or more inputs, and output is high only when the number of high inputs is odd. The high inputs ones or odd number, then the output becomes high. This will be low. Okay. This is Y is equal to A exclusive or B. This is the A and B are the inputs, and we'll get Y here. Okay. Now we'll see the truth table. A, B, Y. Odd number of ones. See the here number of ones. So we'll get output, and cases we'll get low output. And same as exclusive NOR. Exclusive NOR gate. This gate again it is having 2 or more inputs, and the output is high only when the number of high inputs is even number. Reverse. So bubbled with exclusive OR is exclusive NOR. Here you need to use bubble, and the symbol is with equal to A B whole bar, not okay, inverted. So now the table is A 0 0 0 1 1 0 1 1. Now the truth table, that is even number of high inputs. Even now number of high inputs is this is the even number of high input. Here there is no ones. So here this even and this becomes even. So high output and remain two cases. The output will be low. This is about basic gates and universal gates. Realize the given equation, that is y is equal to AB plus C. AB here and this is OR gate. So take one AND gate and give the input A, B, take one more input, that is C, AB output is or the input becomes Y. This is the realization, and you can draw any expression or equation. This is the realization of how to draw the logic circuit using basic gate. We drawn by using universal gates, that is using NOR and NAND gate. Now we'll see what are all the laws of Boolean algebra. Laws of Boolean algebra. Here we are having the op 0, 1. Idempotent, that is x plus x. If they and ORing, then we'll get x and become in is dead. By using gain, if you invert, we will be getting the same as complementary. That is x is an input or with x bar inverted input with inverted or gate, then 1. Fusion commutative law, 2 inputs and y, or you can do I or set x using and y equal to and x. Associative law, that is x plus equal to x plus or y plus z. Same and z also x distributive law. X to y plus z x I x into z. X plus yz is equal to x plus x organs, that x r into this org x and is x y bar. The operation will and to bar is applied for in laws of Boolean algebra. Now we will discuss about combinational circuits of different types of logic gates. The output of combinational circuit depends on the values at the input at any given time. The circuits do not make use of any memory or storage devices. Okay, now we'll see what is a minterm. A minterm of n variables is a product of n literals. Literal is a variable or complement. You can take or a or its complement a bar. It appears exactly once in two or complemented form, but not both. Either will get a or a bar, but not both at a time. Same as maxterm. Of n literals, it is in which it appears exactly once in true or its complementary form, but represent the things. We are taking a c 0 6. The minton, here these are represented with m. 0 is and as low invert a b bar. Next m bar b bar b c bar m a bar m a b bar, because 1, so b and c are inverted c bar. M5, that is a b c. M6 a b c. M7 is written as a b c. Same max presented m what is written as, but here 0, so it is as instead equal this symbol, okay, L plus c. Same as all the done, a plus b plus c bar to a b plus bar c bar. 4 is written as a plus e as a bar b c bar. M6 bar plus c and m as a bar plus c. This is how to and min. Now s, that is product, that is expansion, we call it as expansion or of products. That is a Boolean equation, that is product, logical sum of expression equation apply and or. So PO is maxterm or this is a terms. This is a prof. logical of logic. Equation applies or and. We'll see the combinational. Here we are considering three inputs A, B, and is the combination as equal to of B comma C is equal to suppose of SOP. It is summation M the terms 1 4 5 means the output high remaining 0. Then in terms of POS, that is OP terms M the remainder, that is 0 1 2 3 and 7. Okay, to SOPS. If the given is said to be is 0 1 3 6 7. If suppose 2 4 7 use, then F bar becomes low, high becomes high. This minterm is min. So written. Okay, this is one out. Write this minterm as A bar C, A value C, it is written bar, comma 1, B bar, next B bar, C bar, and last terms. So, function P, reduction of F 3 4 7. Now the function F, this is A bar B C or with A C plus A B bar C plus A B C bar plus A B C. This is the function, and by this we'll get the SOP, that is min terms 3 4 5 6 7. Now from this truth table again we can max terms. Max terms are, now we need to consider ones, that is 0 is taken as A, again 0 B, 0 C. So this is written as A plus B plus C, and next A plus B plus C bar, next term is A plus B bar C, B bar plus C. These are all the max terms. Now we can write this POS as function of F of B is pi of capital K terms of 0 2. So 1, and the function is A plus B plus C into A plus B plus C bar into dot plus A C. This is the POS. Okay, now we'll see completely specified function. Nothing but we can use if suppose a boolean for at least one of its input for any one of this thou don't care for f bar to be specified. Now we'll see one of true completely function. This boolean function whose at least one combination presented with now we'll see the well that a b and the output the combination should be this example 1 0 0 1. This is specified as incompletely specified function. We call it as incompletely specified function. Now this true as SOP, that is f of a comma b comma equals small m of, okay, where we are having put 1 here as well 7 0 comma 7. Here we are having 1 6 are the that means these can be used as 0 care don't the 0 according presented as d of, okay, is 6. POA we can write as a p of m of, now 0 is number 5 comma 4 don't cares, but here we need to represent as dot into of, okay, this is POS. So pi of capital, here we are using small d and the numbers, okay, this is how to write the SOP and POS. And minimum P X, okay, minimize SOP, okay, f of p comma is equal to 1 2 5 6. This is the given expression. Mean that is f is, this is written as means r c bar plus 1 means a bar b bar plus 2 means a bar b c funds is a bar x b 7 p given 0 1 2 5 6 7 0 1 2 5 6 7. Okay, we should take common terms a bar c b bar common, so c bar plus c bar plus c okay, c becomes next from this take b bar, we write a by this becomes and 2 take a plus c expression is plus c. This is to same as POS minimum expression. Well, function is 4 variable, that is pi m of 5 7 6 13 2. Okay, this is written as a plus b plus in 0 1 1 here with bar. This is 7 a plus d bar 1 1 1 7 a bar plus next 41 0 here a bar plus c bar 1 0 a plus b plus 2 into 8 0 1 is plus c bar plus d, and for a function given again we can take common, okay, from this 2
We can take B bar plus D bar common. 2 plus B bar plus D bar common. So C into C bar, that becomes eliminated. That is using the theorem, that is x plus y into plus y x. Same thing changing. So same, if you take bar D bar A plus D bar, here C 2, so B bar terms, this it combines. See here changing, so plus D, and these, okay, remaining terms A B C bar, again by these two terms, that is B bar C bar C bar. Finally is the minimized expression. Yes. K-map. It is one of the method to simplify the given function. This method is faster and easier to apply other than other simplification methods. So we are using this. This is simple and faster compared to other methods. Okay. By using this K-map, now we'll expressions. In this again we are having different variable K-map. K-map of a function specifies a value of a function for every combination of values of the independent variable. We'll take K-map variable. Now we'll see two variable K-map. In this, the number of cells in variable of K-map becomes 2 power 4 cells. That means this is the 4 cells. And the variables we are representing here A, B. First you need to take one is complementary value A bar and same as B bar. Cell numbers, that is A, that is 0, 0. Next A bar B, that means 0, 1. So the cell number is 1, 0, 1. Next is, this is A1 B bar 0. 1, 0 means cell number 2. Next A, B, both are 1 values, 1, 1, that means 3. These are all the cell numbers. Now for example, if suppose the given function, that y is equal to A comma B is equal to summation of 2 comma 3. This is the example. 2 and 3 term and third term output, so this and then minimize. A B bar B. Now where is 2? This is the cell number 2. And next this is the cell number 3. And for remaining cell numbers, place zeros. Okay. This is a. Now we'll see 3 variable
K-map. Three variables means you can take one variable one side and two variables other side, or two variables one side and one variable the other side. Both you can. This is called as row wise or column wise. You can take any one. This side four cells, so two variable combination a bar b bar, a bar b, a b, a b bar. This side only one variable c bar and c. Same as when you come to this is a column, so you need to write variable at one side a bar a and remaining two on the other side b bar c bar, b bar c, b c, b c bar. Now the cell numbers, again you need to check the values of a b c and place the values, that is 0 0 0 0 1 2 3 becomes this, and 5 6 7. These are all the cell numbers. Same as when coming to here, this becomes 0 1, leave one column and go to here, this becomes 2, count this. If you have you can check this 0 1 0, so this becomes 2. Next 1 1, so this becomes 3. Now 4, this and 7. And for example, if you can function SOP with values 3 variable map. Here the equal to p comma is equal to m2 comma, again the 2 6 becomes and remaining becomes 0. Low 2 6 7. Where is the column number? Here and 7. Remaining need to place zeros. And when you come same again 2, okay, 6 7. Remaining cells values 0. Now see the 4 variable K map. Same as this 4 variable K map is, that is variables and remaining 2 variables on the other side. Okay, I am writing, taking A B this side, A bar B bar, A bar B, A B, A B bar, and this side C D, 4 variables A B C D. So C D, C bar D, C D, C D bar. These are all 2 variables on the other side. Okay. Again we example the function no the cell for example 0, okay, 1 for this 2 3, next 4 6 7, one row 9 12 13 14. Okay, example F, B, C, D, 4 variables. Summation M of given example, that is we can take any number 1, 6, 7. That means in the cell number 1 the value becomes high as well, 6 and 7. Remaining all, this will be 0 values. Now coming to minimization of a given expression, that is SOP, or you can take POS also, you can minimize by using K-map. Okay, here again we are having, that is group the variables. How, if suppose add octet. These are the 3 types to group. Okay, pair, pair means we'll check for adjacent. Suppose if there exists a high, okay, adjacent. Now pair eliminates one variable. By this pairing we can eliminate one variable. Okay, pair means check for 2 adjacent ones. It eliminates one variable. Next, quad. Coming to quad, okay, adjacent 4 ones. Adjacent 4 ones. Quad is 4 ones. Okay, this eliminates variables. Same as octet. For 8 adjacent. This eliminates variables. How will an example, that is y is for B, C, D is equal to summation M of 0, 1, 2, 3, 5, 6, 8, 10. Example, now do this grouping, that is pair, quad and octet. Now 4 variable map. Draw the 4 variable map. Okay, consider. Okay, now place the terms, that is here 0 means the output terms 1. Output will be 1, 2, 3, 4, 5, 6, 7, okay, 8. Okay, consider this example, that is 0, 1, 2, 3, 4, 5, 6, 7. Next, 8 is no 8, so place 0. 9, place 1. Okay, 10, there is no 10, so place 0. 11 position, 11 term, cell number. Okay, 1, 11 is there, 1. Next, 12. 12, consider 12. So, 12 is 1. 13, 0. Okay, come to 14. Here again, 1, 14 is there. Next, 0. Now, we'll see how to do pairing, quad and octet. First, check for adjacent ones. Here, there are 2 ones adjacent. So, we can make a pair. Okay, but actually, instead of pairing, first, we need to search for a maximum variable grouping. So, actually, this is called rolling. This corner value, 2 adjacent ones, will be grouped with that corner. So, this becomes a quad. So, by this it eliminates 2 variables instead of pairing. Okay. Next one. Here 8 adjacent values. So, directly we can make octet. Octet eliminates 3 variables. To bother that these already grouped. This the variables you can. Okay. Now 1 and 1. You can do this is again rolling. By using rolling technique, this one and this one becomes a pair. But instead of doing that, if we roll these 2 values, it will become a quad. So it eliminates 2 variables. See, there is a possibility of then it is okay. But no possibility, so we are doing this as a quad. Okay, so all the ones were covered. This is how to make a grouping: pair, quad, octet. First, check for possibility octet. If it is not existing, go for a quad. If again it is not possible, go for pair. If this pair is also not possible, allow the minimized. Now y is equal to minimized expression. See here, this octet. Here the variable which is changed bar, that only we can bar. All the is changing. C bar is changing to D. So all, and that is 4 variables. So changing these 2 variables were eliminated. So only A bar, consider A bar. Next, coming to this quad. Okay, here B is constant, A is changing. So take B and from this end and this end, check the terms. That is variable C bar is changing to C, D bar is constant. So consider which is constant, D bar. Okay, so this quad eliminated 2 variables. Here 3 variables were eliminated. Now check these 2. From this and this, here B bar is constant, A is changing. So consider B bar. And from these 2, C bar changing to C. So eliminate C. Only D is constant. This is the final minimized expression of SOP by using K-map. While doing this grouping, we need to consider points. That is, first one is rolling. That means roll this side, this side, this side, this side, as well corners. If suppose there exists one here, 0 here, okay, you can roll like this the four corners. By this we can get a quad. This is point. And the next one is overlapping. See, already we have done overlapping. This quad, it is overlap, and here also one more overlapping. But because of these two ones and this one, there is pairing said to be overlapping. If this is already done a grouping, then no need to do again as a octet or a quad. Okay, but overlapping. And the third one is eliminating redundant group. That means, for example, here one more possibility is existing, that is you can do like this and form it as a quad. See here, already this one and this one is grouped with the quad as well octet. And same as here, this one and this one is already, this one is grouped with quad, is grouped with, that means we need to make again one more quad. Only one time doing is that. This is what redundant group. These are two we need to consider. The using the technique, here some of the limitations. The number of variables in process increases. This is one of the limitation. Now we'll see one more example to solve POS. Okay, take an expression, that is y is equal to f of a b c d is equal to pi m of 0, 2, 3, 8, 12, 14, 15 with don't care. That is don't care is 1, 4, 5, 11. Consider this example. Here what to do is, okay, don't care means wherever it is necessary, let it actually we place ones, because grouping ones coming to P of 0, zeros were, will see the example. First, write the plus reverse. So as it is a bar, will a bar and a next C. Okay, finish. Okay, and as it is here, there exists there first z. Okay, here so place z. There is no 1. Leave it as it is. Next to 2. This is 2, 0, 3, 0, 4. There is no 4. 5, no 5. 6, no 6. 7, no 8. It is there. so place 0. 9, no. 10, no. 11, 12 is there, okay, 12, so place 0. 13, no 13. 14, yes, 14 is there, so place 0. And 15, place 0, okay, 14, 15. This is how to place the, that is POS, pi of. Okay, next into pi of, this is don't care. 1, 4, 5, 11. Okay, don't care. So 0, 1, don't care. Okay, 2, 3, 4, don't care. 5, don't care. 6, 7, 8, 9, 10, 11, don't care. Okay, remaining you just place once. Now in POS method we need to group zeros. Please remember that you need to group zeros. Now if there exist as adjacent zeros, okay, go on grouping. Here actually see here 0 adjacent, there is no 0, okay, but you can consider any don't care as 0 and you can group it as a quad, but there is a possibility of grouping these as a quad, so we are considering this don't care as 0 and grouping this as a quad. Okay, next come to here, there is 2 zeros plus again 1 don't care. Again you consider this as a 0 and group it as a quad, because hearing if you do quad it eliminates two variables. Simplified expression again don't care is there but 0 is not existing. Possibility of making a quad, make a, okay, this now becomes equal to, see here this 4 2 weighted constant plus d into, here all will be changed, b constant, this pair, okay, here a bar plus b bar both will consider, plus from this, okay, d is changing so eliminate and c bar will be considered. So this is the POS minimized expression. Now we'll solve one of the problem by using K-map, that is the given SOP is minimized using K-map. Now we'll draw the K-map. Take one side and other two variables at the other side. First a bar b bar, b, a b, next a b bar is the one side and other side c bar d bar, c bar d, c d, c. Now we'll place the given the cell number, that is 0 1 3 0 place, this is the place 1, next 2, this is 2, 0 because 2 is not given, 0, next 3 is given, place next given, so place 0, 5 is given, so place 1, 6 is given, this given, place 1, next leave this row and this is the 8, cell number 8, it is not given in SOP, so place 0, 9 is not given, so place 0, next leave 1, 10 not given, so place 0, 11 is given, so place 1, Next 12 is given, place 1. 13 is not given, so place 0. 14 is given, place 1, and 15 is not 0. Now solve this using the first we need to for maxterms, that is octet. Is there any octet possible here? No, it is not possible. So go for searching a quad. Yes, here we can make. So make it as a quad and check the other possibilities if there exists any quad. No, there is no other quad possibility. So go for pairing. These two we can pair. As well, these two ones you can pair. Adjacent. Okay. Now see this. This one is alone, but by using rolling method, this one can be paired by using upside down. As you write that there be one. Okay. To do the session K map. Now we'll simplified expression. Before going expression, one more it is possible actually, and this paired way grouping. Need to pair. This becomes reduce duplicate overlapping. Okay, duplication. No need to duplicate the pairing, that is grouping. So now we'll write the simplified expression S is equal to, okay, from this B bar, A bar, B bar is constant because only one row. Consider A bar, B bar, and from here D bar is changing to D. That means eliminate D and consider C bar. Plus, next check here these two rows. Okay, B is changing, so eliminated bar is considered. From these two columns, D is constant, C is changing. Leave this and write the D. Next, coming to CD bar, and the last row is AB bar. From this to B bar is constant and A is changing. So consider B bar plus this pair. That is from this B is changing. So only take B and here C and D bar, because only we need to take plus 2. A, B only one row, you need to consider AB as it is, and from column D bar is changing, take D. This is the simplified. And here you can get one more simplified the another way, that is, for example,
as a pair, then these two pairs will get A from this. So A bar B here C will be instead of B C D bar. Instead of B C D bar, you can replace with D. That means more expression A bar B plus C plus A B A bar B A B D bar. Both you can do like if this will be the expression, this pairing, this will be the. This is how to simplify, that is minimize using map. Now we'll see how to design circuit for this minimized expression, that is for S. Okay, we are having this. We are taking A as A bar is also designing the circuit. This is for S expression S. Take the NOT gate. This will A bar B gain 7 or inputs. Design A bar B gate. That means connect A bar B bar and C bar using AND gate. Next A bar D, put A and D another two input. Next input is okay from C. Next another B bar gate. Next D bar E C and gate. The last term is D bar. Connect E and input A bar. Now all the term this and this is design. This will be helpful to design full adder, full subtractor, binary to gray, gray to binary. All these circuits in your lab experiments. We'll solve one more problem, that is minimize using 4. See here be given. Okay, BCD is summation M of 2, 3, 5, 7 plus 750. Solve this problem using K map. Take two variables, A be this side and C the other side, and okay, place the numberings, that is 0, 1, 2, 3. Okay, now 2 is given, so place 0, 1, 2 position 1, 3, cell number 3, 1, cell number 5, that is 4, 5, 1, 6, 7, 1, 8, it is not given, 9, not given, 10, so given 1, 11 is not given, but actually it is in don't care, so write don't care with X. Next 12
is given. So place 1. 13 is not given. 15 don't place, don't care in. Now you need to consider 0. Now we'll do minimization. See here, but means here don't care, you can place either 0 or 1 according to our requirement to minimize the expression. When you consider this don't care as 1, okay, then you can do quad by using rolling method, okay. And see one more possibility, that is you can do here quad, okay, by considering this don't care as 1. This don't care can be considered as 1 and you can make this as a, but one more possibility of pairing is existing. If you do pairing this, no need to take this because unnecessary care and grouping is increases the circuit design. So here you do, okay. Actually possibility maximum is present. Don't care, it is not a 1. So considering this don't care as 1 and making this as a quad, okay, one more extra term will exist. Because this is alone, you cannot do any possibility of pairing. So it should pair with this adjacent already. So no, again quad. This again, if you do quad this becomes duplication, redundancy will. So no need to do this. Next, see here, this is a 1. Okay, this 1 you check for rolling, okay, not possible, or adjacent values. This. No, there is no adjacent one. No adjacent one as well. Rolling is also not possible. So is this one as a individual term. And now the minimized, that is minimized from a bar. Here D is constant. A bar B in plus term. So A B bar. This constant B bar and 2 is this final. This again you can design the circuit. Now minimize the given POS using K-map. This is POS. So wherever the terms, that is values given, that cell number you need to place with 0 instead of, for SOP we are, for POS you should place 0. Same procedure. Okay, 0. So in the cell 0 you need to place 0. 1, 2, 3, 4, 5. So here place 0. 7 place 0 is because 6, 7, 8 exit 0. 9, 10, 11 not given. 12 again 12 is there, place 0. 13 is there, place 0. 4 0. Next 15 is there, place 0. Okay, remaining and all you need to consider as 1. But here when you are using POS, that is pi of capital M, then you should group zeros here. So now this is one quad. Okay, again there is a maximum possibility of grouping is again one more quad. Now make a pair with this adjacent, and this is alone, but here using rolling method you can do pair. So look at here, already this 0 is paired with rolling 0. This 0 required to group this as a pair. This becomes again duplication. So the final f is equal to the final minimized expression, that is from this AB constant. You need to consider AB, but here this POS expression, so we should write A bar plus B bar, and this side all were changing, that is C is changing as well D. So into, next from this quad, here B is constant, that means B bar, plus here C is constant, that means C bar, into, next this is a pair. By this B bar is constant, A is changing. So B bar means you should consider B, C bar, D bar means D. This is how we need to POS minimized expression. You should group zeros, the given SOP, place zeros and group zeros and write wherever it is the term existing, that is if suppose you should place A bar, if it is A bar you should place A. Okay, this is what proceed. One more example for POS, that is pi m of, okay, with don't care. Okay, now we'll solve this by using map for don't care. Draw the K map, place the variables. Okay, now what are all the terms given, that is 0, 2, 3, 8, 12, 14, 15. 0 you should 1 not given, 2 place 0, 3 place 0, 4, 5, 6 given, 8 give 0, 9 is 10 not given, 11 not given, that is given place 0, 13, 14 given place 0, 15 given place 0. Okay, don't care. Yes, don't care. 1, next 4, 5, 11. 1, 0, 4, 5 don't care. Okay, 8 is don't remain. You place the zeros. Grouping, you can consider this don't care here as 0. Grouping in SOP, the don't care is considered as 1. Here you can consider it as 0. The maximum possibility is possible for quad. So you consider it as 0. Okay, quad. Okay, and again quad is existing here. Okay, quad is existing. You can do quad to eliminate one, that is consider again there. Okay, and here there is no possible, it is 1, so the possible to pay the expression. From this all are changing, so leave a bar plus b bar. From this bar d bar should write, and here a c is bc, a bar c bar. This is final expression map for s. As by a map similar, the limitations of whereas the application or option will next method, that is quine mcclusky method. Now we'll see the procedure how to do the simplification using this method. This method involves preparation of two tables, that is one is determining implications and other is essential prime implications to get minimal expression. Prime implicants are expressions with the least number of literals that represents all the terms given in a truth table. Prime implicants are examined to get essential prime implicants for a particular expression to avoid any type of duplication. This is how to solve the given SOP by using this method. Actually, this method provides a systematic simplification procedure that is actually readily programmed for digital computers. Now we'll see the procedure, okay, with one example. The given SOP is f of a, b, c, d is equal to 0, 1, 2, 5, 6, 7, 8, 9, 10, 14 using mcclusky method. Okay. In this procedure having two steps. The first step is arrange the given minterm. That means we need to write minterms for this for writing that. We'll see the procedure, that is ascending order. This should be, that means ascending order, that means ascending order groups based off ones. What first I'm making with ones, that is the to 0, that means all 0. So 1 0 0 1 again will be having 1 based on the number of ones I'm grouping. Now 5, that means 5 is 0 1 0 1 0 1 0 1, that means here two ones existing, so I'm writing as another group. Next 6 0 1 1 0 0 1 1 0, two ones, so making it as a group. And 7 means 0 1 1 3 ones, so make it as a group. 8 is only 1 1, so place that in the previous group where there exists only 1 1. Okay. 9 means 1 0 0 1, that means two ones, so place here 1 0 0 1 where there exists two ones. Here there exists two ones, only 1 1. Next 10 again 1 0 1 0, that means only two ones, 1 0 1 0, place here itself as one group. Next 14 means 1 1 1 0, that means three ones, so three ones group. Okay. Now while writing the minterms, I have grouped 8 as, this is 5, 6, 9, 10, 10, 14, and this is 8. Okay, these are all the minterms with grouping. Now, stage 2. Go for stage 2. We need to each and every group with other group. If there is a change in only one bit position, then take a pair of those two minterms. That means we need to pair those two as a 1. Place this symbol, that is symbol is hyphen, that is minus, in the different bit position. Different bit means where the bit is changing. In that position, we need to place hyphen, that is, and keep remaining bits as it is. Now, I will show how is it. That is, see here, we are comparing this minterm with all other terms in the other group. Okay, this group compared with the other group. So 0 0 0 with this. So all the first 3 bits are same and the last bit is 0 is changing to 1. So make it as a pair and keep first 3 bits as it is, and it is changing in the 4th position. So place hyphen. Same as it is again with 0 with 2. So pair it again 0 2, and at the second position, that is 0 0 hyphen 0. Second position it is changing. Next here it is in first position 0 8 hyphen 0 0 0. Completed. This comparison with the other group is completed. Now compare this group with other group. Okay. Here bit 1 is not changing, 0 is the same. Here 0 is changing to 1, that means the third position, that is 1 comma 5. Okay, 0 is constant and changing 0 1. Next again this with the next second one, that is, see here, 0 changing to 0, 1 change, again 0 is changing to 1, 2 change, and 0 is changing to 3. 3 changes. So we cannot group this. Only one change should be taken place. So no need to group these two. Next, compare this with the 9. Yes, it is possible. 1 0 0, 1 0 0 is constant. Only this is changing. That means 1 comma 9 is paired. 0 0 1. Next, again this with 10. It is not possible because 1 change, second change, and 3 changes. So no need to pair. Next, compare the 2 with all this group minterms. Okay. Here 0 is changing to 1, 1 is changing. So leave it. If more than 1 change, leave it. Next, coming to next. 0 not changing, 1 not changing. Here it is changing. Here it is not changing. So 0 hyphen 1 0, it is grouped with 2 comma 9. Sorry, not 2 comma 9, 2 comma 6 it is. 6. Now 2 comma 9, it is not possible because 0 is changing to 1 and 1 is changing to 0. Leave it. Okay. Next, coming to 2 and 10. 2 0 1 S 0 1. Yes, possible. So group 0 10, 2 comma 10, that is 0 first bit is changing, hyphen 0 1 0. Yes, this all group terms minterms were compared with the other group. Now compare this group with this group. 1 is constant, 0 is changing, 1 is constant, 0 is constant. So grouping is possible. 5 comma 7. 0 1 hyphen 1. Next 5 with this, that is changing, again changing, not possible, so leave it. Next compare with 6 and 7, it is changing and remaining 3 are constant. So 0 1 1 hyphen, that is 6 comma 7. Next, yes, it is possible. Last 3 bits constant and this bit is 6 14 1 1 1 0. Next 9 with 7 change, constant, it is changing, this is changing, so not possible, 2 changes, leave it. 9 with 10 changing and to second bit is also changing, so not possible, leave it. Next 10 with 14, first bit not changing, second bit not changing, yes, third bit changing, fourth bit not changing, so it is possible. 10 comma 14, that is same 1 hyphen 1 0. So second stage is completed. Now we are going for third stage, stage 3. Okay. Now compare this group with this group. Only one possible change. Okay. Check with hyphen, not existing. So group this with this value. The hyphen, check for hyphen. Here it is. One hyphen is existing. So check the next bits 0 0 0 0. Okay, one bit is changing. So 0 1 comma 8 9 pairing is possible. That means first bit value is changing. So hyphen, next 0 0 hyphen. Next any other match? No, there is no other hyphen at the end. So 0 1 is completed. Next 0 2. Check for the second position hyphen. Second position hyphen, it is there. Okay. 0 hyphen 0 is constant. It is changing. That means hyphen. Okay. 0 hyphen 0. That is 0 2 with 8 10. 0 2 comma 8 10. 0 8, that means starting position hyphen 0 1 9 1 9 0 8 with 1 9 hyphen 0 0 constant hyphen 0 0 constant, it is changing, so place hyphen. Okay. Next one more possibility. Okay, yes, it is 2 0 is opening, so no need to again group this, only one time is enough. Okay, now we'll compare this group with this group, that is hyphen in the third position. Yes, here it is. Okay, 0 is and hyphen again 0 is, so grouping is possible. Again check hyphen positionability. Hyphen, next 0 is changing to 1, 0 is changing to 1, 1 is changing to 0, so not possible, leave it. Next go for 2 comma 6, that is hyphen in the second position, hyphen in the second position, this. Okay, we'll check this. 0 is changing to 1, hyphen is constant, 1 0 is constant, so this is possible. So 2 6 comma 10, 2 6 comma 14, that is 2 6 0 is changing hyphen, next again hyphen constant, 1 0 constant. Okay, next 2 10, that is the first position hyphen, yes it is, yeah. So next position is changing, so hyphen, next two positions constant, that means hyphen hyphen 1 0. This is same, hyphen hyphen 1 0, same, so no need to again group this, so leave as it is. Okay, so these are the last grouping terms at the stage 3. Now we'll see the prime implicants chart. This prime implicant chart consists of rows and columns. That is, in the row we should write minterms. This is here. In the row we should write minterms. So these are all the prime implicants. Now we'll write this prime implicants as a row, as one row. That is, see here, this is the 0, 1, 8, 9. Okay. Next one is 0, 2, 8, 10. Next one is, see here, 0, 8, 1, 9. It is repeated. Okay. So no need to write again. 2, 6, 10, 14. The prime implicant we have in the stage is not, okay, 9, okay, not covered. As well, 5, 7 is not covered and 6, 7 is not covered. When we are grouping, these were not covered. That is, see here, more changes. Okay. So this is not covered with any other grouping minterm. So we need to consider these in essential prime implicant, that is 1, 5, 5, 6, 7. Now we'll write what are all the terms. That is, this term is A, B, C. That is C bar, B bar, 0, 0. Next, B, C. That means A bar, C bar. Sorry, C, D. I'll write this here, variables. First one is okay. Next one, this is A, B, C, D. So, B and D. So, B bar, D bar. Next, coming to this is C. 0 means D bar. C, D bar. Next, for this, what is the minterm is A0, A bar, C bar, D. And for this, A bar, B, D. The next is A bar, B, C. These are all the minterms which are SOP at the column side. Yes, written 0, 2, 5, 6, 7, 8, 9. Now place 1 in the cell corresponding to the minterm that are covered in each prime implicant. Suppose for each prime implicant, if it is covered, okay, place here 1 or you can place cross. In this position, if this minterm, okay, is covered for prime implicant, then place 1 or cross. Okay. Now we'll write that. See here, 0, 1, 8, 9. That means 0 cross, 1 cross, 8 cross, 9. You can use cross or 1. No problem. Cross or 1 you can use. Next, 0, 2, 8, 10. 0, 2, 8, 10. Next, 2, 6, 10, 14. 1 and 5. Next, 5 and 7. Next, 6 and 7. Now by observing the each column we can find out the prime, that is any min is only one time in this table, that is one time min to be essential prime implicant. Okay, we'll check that. The min term, if it is covered only one time, that means this 0 min term is covered 2 times, so no need. Next one is covered 2 times, no, not required. And 2, it is not prime implicant. Next, this is not, it's 7 2 times not, 8 2 times 1, 9, only 9 is covered one, this becomes essential prime implicant, that means B bar C bar. Next, this times is essential prime implicant, yes, again 14, that means 14 is in here. Writing the simplified is 2 or that means include in your min term. Okay, so these are the two essential prime implicants. Okay, because these are covered only one time, remaining and all covered 2 times, so these two are becoming essential prime implicants. Next, reduce the prime implicant table by removing the row of each essential prime implicant and the column corresponding to the minimum terms that are covered in that essential prime implicant. That means, see, this is the essential prime implicant as a row, and which are all covered, remove that, yes, that's it. And again the essential, make a row, and which are all the prime implicants covering this, remove all this, and only the remaining is 5 and 7, only this is the, and this is 7, so consider this 5 7, that is A bar BD is taken. So this is the simplified expression using quine mcclusky method. Simplification of incompletely specified functions, that is given incompletely specified function, that means the proper assignment of values to the don't care terms is necessary in order to obtain a minimum form of a function. Okay, now we'll see that, that means wherever there is a don't care, we need to place with the proper value, whether it should be 1 or 0. This is what the unspecified function. Now we'll see the example, that is SOP is given, that is f of ABCD is equal to summation of 2, 3, 7, 9, 11, 13 plus don't care 1, 10, 15. This is using mcclusky method, using quine mcclusky method. Now the same part we need to don't care. First, stage 1, write the min term according to the number of ones to group. Okay, now 2. Actually we need to consider don't care also. So 1, that is 0 0 0 1. Next 2, 0 0 1 0. 3 is next group 0 0 1 1. Next 7 is another group 0 1 1 1 because 3 ones means 2 ones. So 9 is considered in the second group, that is 1 0 0 1. 10 is 8 plus 2, this group 8 0 1 0. 10 11 means next group, that is 8 9 10 11. Next 13 means 0 1. 13. Next last one is 15 1 1. This is the first stage. Stage is completed. mcclusky. Next say stage 2. Now go on, compare the two group minterms and pair. Okay. If there only one change, 0 0 hyphen 1 1 comma 3 0 0 hyphen 1. Okay. Next 0 0 1 0 0 1, that is 1 comma 9. Next it won't change because 1 is changing, 0 is changing. Okay, we cannot pair. Next 2, that is 0 0 0 hyphen 0 hyphen, that is 2 with 3. Next 2 with is not possible because 0 is changing and here 1 is changing. 3 changes we cannot pair. So next 2 with 10, yes, it is possible, that is hyphen 0 1 0 10 hyphen 0 1 0. So coming to comparison, that is possible 7 0 and 1. Next 3 11 possible with 11 hyphen 0 1 1. Next 3 with 13 is not possible. Okay, leave. Next 9 with 7, not possible because not is possible. Hyphen 1 1 0 hyphen 1, that is 9 with 11. Next 9 with 13, 1 hyphen 0 1. Okay, because 1 constant is 0 1 constant. So 9 with 13. Next 10 with 7, change not possible. 10 with 11 is possible. 1 0 1 constant and it is changing. So 10 with 11, 1 0 1 hyphen. Next 10 with 13, constant changing not possible. So second group comparison is completed. Now compare this with this. Okay, that is hyphen 3 ones hyphen 3 ones possible hyphens. Next 1 1 1 15. Next 13 with 15 is possible because 1 1 hyphen 1. Okay, now the comparison is completed. Next again stage 3, this group with this group. Okay, now see this hyphen in the second position, only 1. Okay, hyphen in the second position. Hyphen 1 0 is possible. Hyphen 0 hyphen 0 hyphen 1. That means 1 3 and 7. 1 3 9 11. Next, hyphen, yes, 0 hyphen 1. That means 9 and 3 11. Same, 1 9. So no need again. Same repeating. Only once is enough. Next 2, that is last hyphen reality. 0 is changing, not possible. So leave. Next, compare there 10 to 10 is hyphen starting. Okay, hyphen starting 3 11. Yes, 0 constant, it is possible. 2 10 3 11. That means 2 3 10 11. Okay, that is high 0 hyphen, sorry, 1 hyphen hyphen 0 hyphen 0 hyphen. Okay. Next, 2 10, that is starting to 10. So this comparison is completed. Now compare this group with this group. Okay. Now we'll check the second place hyphen, only one possibility. Okay, 0 is changing, hyphen 1 1. So hyphen 7 15. Hyphen hyphen 1 1. Okay, next 3 11. That is starting hyphen. Okay. Now next, this third position hyphen. Yes, here it is. Third position hyphen. Yes, possible, because 1 hyphen hyphen 1. 1 hyphen hyphen 1. Okay, that means 3 15 9 11. 11 in sequence. This second position, I think already 9 3 15. Next 10 11, that is last hyphen There is no last type. Comparison. Good. Now we'll see the chart. Prime implicant chart. Prime implicant as a column only minterms, not prime implicants. That is, this is 1, 3, okay, 2, 3, 7, next 7, 11, 11, 15. This side, then 9, 13. Now, prime implicant covers here. It covers because one need to consider either you could place 1. Next 2, 3, 10 is on, leave 11. 3, 7, 10 is done. 3 again, 11, 15. Sorry, 1 minute. This is the right 13. Okay, 13, 15. We'll check terms number of times this applicants in the only one, 2 time, only 1 time, and time essential prime implicant. So going first process. Okay, prime implicant 3 or implicant 1 is left. Is compromised. That is, what is this value? That is E bar plus this D AD. This is the finalized incodified form. That is nothing. Petrix method. So use to minimize the actually in mcclusky. Okay, 2 minimum in prime. This petrix all from applicant chat. So we are doing petrix method. The first procedure is same as mcclusky. This is the NSO to write the 0, 0 as grouping 2, 5, 0, 1, 6, 1, 1, 0, 7. Okay, this is the. So compare this. There exists only one bit position changing. Then pair it. Okay, yes. 0, 1 only. One difference, that is 0, 0. Next 0, 2, 0, 0. Group 0, 0, 1, 1. It will be group, that is it is changing hyphen 0, 1. 1 with 6 is not possible because 1 is changing to 0, 0, 0 is changing. No. Now compare with the 2, that is not possible because 0 is changing as 1 and 1 is changing 2. Changes not possible. Let's compare this with this. So 2 comma first position, then next these 5 yes 1 next changing, next 6 possible, 1 1 hyphen. These are the prime implicants. Okay, from this we are constructing the prime implicant chart and finding the essential prime implicants using mcclusky method, right? But here we are writing the prime implicant chart. Prime implicant terms, minterms. Okay, prime implicants. These are all the prime implicants. Name it as P1, P2, P3, P4, P5, P6. And what is P1 is 0 combined with 1 pairing. So this is when you take A, B, C variables. Now A bar, B bar. Next P2, that is 0 with 2. A bar, C bar. 1 with 5, that is C. Next 2 with 6 bar. Next one 5 with 7. A, C. 6 with 7, A, B. Okay. Intro 1, 2, 5, 6. First minterm, that is next. So 0. Next 5. Next 2, 6. 2 with 6. Next 5, 7. 5 with 7. 6, 7. 6, 7. Check here. Actually 0 is covered 2 times. Okay. 1 is covered 2 times. All were covered 2 times. So there is no essential prime implicant from this. If you want, you check this. Yes. So we are going for the next procedure, that is, now you group the prime implicants, that is P1, 2, where because these two were covered with minterm 0. So finally represent Petrix method with capital P. So P1 plus P2. Next P1 with P3 because it is covering P1, P3. So right here P1, P3. Next P2 with P4. P2 plus P4. P3 with P5. P3 plus P5. Next P4 with P6. P4 plus P6. Next P5 with again P6. P5 plus P6. Now we'll simplify by using this method. That is using distributive law, this will become P1 plus P2, P3. Next coming to these two, okay, P4 distributive law plus P2, P6. Next coming to these two terms, P5, P3, P6. P1 with 4, P1, P4, P1 with P2 P6. Next, this two, that is P2 P3 P4 plus P2 will get 2 times P2 P3 P6 this you can write only once P2 P3 P6 into P5 plus P3 P6. Okay. Now again you do the same process for P1 P4 P5 P1 P2 P6 P5 P2 P3 P4 P5 plus P2 P3 P6 plus again for this two P1 P2 P3 P6 again repeated, so no need to is enough. P1 P4 P3 P6 plus P2 P3 is repeated 2 times, write only 1 time. P4 P6 plus here P2 P3 repeated, only write 1 time and P6 1 time. Use x plus x y is equal to x to eliminate the redundant terms. Okay, we'll eliminate the redundant terms. That is 1 4 5. Is there any 1 4 5? Yes, 1 4 5. This term this will be as it is. This. Now we'll see 2, 3, 6, 4. By using this, 6 will be eliminating. So this will get 16. P2, P3, 2, 5, 5 removing. Next again 2, 3, 6 with 3, 6. 6 P eliminate. So finally 1, P2, 6 will be 2, 3, 6 will be exist 4 terms. That is 5, P2, P5, P, P4, P5 S, P4 that is P3 in P4. Finally 1, 2. This is final minimum. From the matrix expression, we'll get two solutions. That is minimum number of seconds. Minimum, this is the minimum number and a number. Solutions, that is P5, P2, P3, P6. Okay. Now check that F is equal to what will be the, there is no 1, 4. Next 1 is here, 1, 5. Okay, wherever 1 it is covering, we'll check that 1, that is 1 is A bar, B bar. Okay, here it is covering A bar, B bar. Here it is covering 1 as, so C, B bar, C less 5. It is covering 5 as A. The expression 2, 3, 6, K2. That means is equal to C bar plus B bar, C plus 6, 2, 6 or 6, 7. That is AB. Again that is cover terms. So one is and other, that is B, C bar, or for these are all the is the minimized SOP. Discuss to simplify SOP or this minimize given SOP, that is or it is entered. This increase the of K map. It means it allows a smaller map large number of variables. This is done is by writing output input. See this MEV input. This is the entering the array using output in terms of this input. Okay, how this is? It is having some the input MEV variable output is 0 and in combination output both, so we need to enter 0. Both enter 1. Out input both are as well. That means input outputs. So enter MEV. MEV is nothing but input is 1. Output is inverted. So MEV input inverted value bar. Now when
That means you can do. So entry becomes 0 and don't care. Place this don't care with 0, 0. 0 don't care. This becomes output 0. 1 don't care is replaced with output becomes care. So don't care is so enter variable. This is enter MEV entry by using the exam. That is SOP is FC is equal to summation of 0, 1, 2, 5. This is the given. Okay, this the output 0. Need to variable combinations 0, 1, 2, 3, 4, 5, 6, 7. All the given and to put 1, output 1, out for 3, 0. 5, it is output 1. 6, it is 7, 0. Will M. Now, the C, the output. Combinations 1, 1, 3, 1, 1, 0. Input and output are so that means here considered as C. Input and output V means so enter C or 0. Complete the table. 0, AB, AB. Put the input is C. Combinable 0, 0, 0, 1, 1. Now the output entry E will draw the K map. Only two variable map A, B. A bar, A bar, B other side. Now you place this 1, C bar, C, 0. This is how to solve, that is minimize the expression. Three steps to get the minimize expression by schema. The first step is first place C and C bar as zeros. So from this you need to place zeros where there is a C and C bar, zeros, and here 0 right as it is, and 1 right as it is. Okay, 1 is written as it is, 0 is written as it is, and C bar replaced with 0. Now we will get one SOP, that is A bar, B bar. What is this? This is single. Okay, only single. So we'll get B bar. So P. Now next, that step 2. Here what we need to do is C you need to consider and C bar big, that is to 0 and 1, and wherever there is a 1 you don't care, that is 1 is equal to don't care. In this first case C is equal to 0. The second case, C is equal to 0, C bar becomes 1, and wherever there is a 1, place don't. Okay. Now, here square, it is C, placing 0 C, and C location cell, placing 1 as 0. In the first step, what we have did is C is equal to C 0. So, C and C 0, 0, it is 1 and 0. So, if do it, so A bar, B bar, we'll see that is C equal to 0, C 1, and replace 1 with don't. Here, replace with don't. C becomes 0, C bar is and becomes A. Now, here, we'll write the SOP2 as now. What will be the expression is here A bar. This in C. Here, this becomes C. Here it is C bar as 1. So this V bar. So this SOP becomes A bar C bar. Next, same as third step. Again, we'll write the K map. A bar A, B bar. Now in this, what we'll consider is one wherever there is a replace with one, replace, and reverse C is repo. Now C is 1. That 1 becomes C becomes 1. C 0 as it is this 0. Now do the pairing. We'll get the SOP. This is the pairing. So now we'll get SOP 3, that is only B bar. So only B bar into T. So we'll get B bar C. Now we'll consider all these three and we'll write the minimized function, that is F is now F becomes A bar B bar plus A bar C bar plus B A bar B bar plus C bar plus B. First SOP A bar B bar and second SOP A bar C bar and next SOP B bar C. This is the final minimized expression. Now we'll see one more example, that is 4 variable SOP. Here in this summation M of 2, 3, 7, 6, 7, 9, 10, 13, 14. This is the given SOP where there is a output that is here in this terms. You should write 1. Okay, we'll write all the 4 combinational values 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. 0 to 15, 4 variable combinational values. Now we'll write the output 2, 3, 0. Well, no term is given 0. 2 is given. So write 1, 3 is given. Place 1. Next 6. This is the 6, 7, 8, 0, 9 is given. 1, 10 is given. 12, 10, 1, 11, 0, 12, 0, 13 is given. So 1, 14 is given. 1, 0. This is the output by using this SOP. Now we'll enter the MEV. MEV entry. See, these two outputs 0. So enter value 0. Outputs 2 outputs 1. So enter 1. Again 0. Enter 0. 2 values 1. Enter 1. Input as well output both are same. Enter MEV. MEV the input variable D. So enter D. Now input 0, output is 1, input 1, output 0, inverted values. So MEV bar, that means input MEV D, D bar. 0, 0, 0, 1. So input output same. So D. 0, 1, 1, 0. Inverted value. So enter D bar. Now we'll write this as a 3-variable map. Considering only A, B, C 3 variables, and these are all the 0 to 7 combinations. That is cell number 0, 1, 2, 4, 5. Already as we discussed in KMA previous. A variable one side and BC variables the other side, and enter this outputs in the cell number. So according to 0 cell number, 1 cell number 1, 0 number 2, 1 cell number 3. Now coming to cell number 4, D, 5, D bar. This is 6, D, 7, D bar. Now according in this MEV, that is the first step is place where there is a D and D bar with 0. Here these 4 D, D bar all becomes 0. As this value 0, 1, 1, 0, 0, 1, 1, 0. Now make a group. This is a pair. B variable changing. Eliminate the B. C is constant here. A bar is constant. Now this becomes A bar C. But the occurrence of D bar is 0. There is no occurrence of D bar. So no need to consider D. Now this is the first SOP. SOP1 becomes A bar C. Coming to the next step in this, replace 1 with don't cares, and D bar is 0. So here there is 2 1 replace with don't cares. Where there is a D, these two equations D numbers. So replace with automatically D bar cells becomes 0. Again now pair. Okay, because we can pair only once. These don't case were not used. So pair these two. In this, we'll check, that is B is changing, eliminate B. C bar is constant. So consider C bar as from this C bar, but this is the occurrence of D. D is 1. We are considering D is 1. So occurrence of D. So this is the SOP to A C bar with occurrence of D. Now the third step, that is same, D becomes 0, D bar, that means this is the occurrence of D bar in this. So we'll write the final expression with D bar and we'll write it as it is 0 wherever there is 1, replace with don't care. Wherever is a D, replace with 0. Wherever there is D bar, that becomes, now use grouping map technique. This don't care, we are considering it as 1 and grouping it as a quad. Quad eliminates two variables. A is eliminated as well. Here B is changing, so eliminate B. Only C will be remaining. This is the C, but this is the occurrence of D bar 1 1. So write a D bar. This becomes SOP 3. Now the final minimized expression is F is equal to A bar C plus A C bar D. Plus C D bar. This is the way how to minimize the given thing, or this is also said to be EVM method. Please do subscribe and share my video.
Myself Ushashree. Now I am going to discuss about Module 2, Analog and Digital Electronics. First topic is, what is analog electronics? Is an electronic system where signals change continuously. Analog signal is a signal whose amplitude can take any value between the given limits. A continuous signal, that is analog circuits, operate on this. Now coming to digital electronics, it is a field of electronics involving the study of digital signals. Digital signal is a signal whose amplitude can have only given discrete values between defined limits. Operate on digital signals. Coming to periodic waveform used as a base timing signal. From this, we click the duty cycle, that is duty cycle, periodic digital signal is, it is the ratio between level time, that is on time, high level time, and the ratio between low level time, off time. Low level time is off time. This total on time and off time is set period. This is on time, we call it as TH, high time, TL, time, low time. Total this is said to be from this we can calculate the frequency. Frequency is equal to 1 by time period, total time period. Now that is duty cycle is calculated as duty cycle for high H divided by total time T. Same as duty cycle for low is calculated by total time. This is how calculate the duty cycle. Now we'll see what is a digital circuit. It is having one or more input signals, but only one output signal is called gate. It is having inputs. You can give any number of inputs, but output is only one. Logic circuit is a ditching or any kind of two states on state. Here having here basic gates. We'll see what is the basic gate, not gate, inverter, or gate, and gate. Three basic. First we'll see a gate with own complementary output. That is, this is the diagram, not gate. Only input is and inverted output, not put table A. If A is 0, Y output becomes 1. If A is output becomes 0. Is converted output. Now coming to OR gate, a gate with two or more inputs, but output will be only one. It is high. This is represented with OR gate. This is the logic diagram, and the symbol used is plus. Inputs B and the output is Y. So Y is represented as Y is equal to B. Y is equal to A plus B. Now we'll see the truth table inputs, bit values 0, 0, 0, 0, 1, 1. For this, we'll see what is Y output. That is A plus B. Or that means inputs are low, then the output will be low. Otherwise, for all other cases, high. Now we'll see the AND gate. Again, this gate is also consisting of two or more inputs. Output is high only when all inputs are high. Logic diagram. For AND gate is two inputs A and B and the output, and the symbol dot Y is equal to A dot B. Truth table A, B, 0, 0, 0, 1, 1, 0, 1, 1. When the output becomes high is high. Remaining all cases 0. Inputs are the output will the basic gates. function that is created using only such gates or unit gate or NAND gate. These two are said to be universal logic gates. The representation or S, okay, and or means bar. So y is equal to, if we are inputs a b whole bar is said to be NOR gate expression. Diagram or bar or a b and y. Bubble is nothing but not or plus not. This is the NOR gate. And truth table A, B or gate inverse. That is, for outs or low, the out will be coming if both the inputs are low, then the output becomes high, and for remaining other cases, it will be low. Now we'll see the universality or how this can working as AND. Say this, input A is given for that A inverted out. Okay, so this is working as or not. Now we'll see or. When you give 0, okay, one input, that means both are 0, so the output will be 1. A for both inputs, so it becomes 1. When you give 1 and when you, that means both inputs are high, automatically the output is 0. Okay, how to check the values. Now we'll see for R. Connecting to NOT gate. Already this NOT is working as NOT gate. So draw that single input NOR gate. Now we'll check the truth table. Now this Y output is equal to A plus B. Okay, we'll consider two inputs. Suppose, for example, 0, 0. Okay, the output becomes 1 when the reversed output is 0. So, or output. Next, when we give these all, this will be again get 1. So, it is working as OR. Now, we'll check for A red input and these two are again for no. So, now output checking for AND gate. The AND gate is if both the 1, y becomes 1. 0, 0, that means out 1, 1. 1, 1 means 0. Next, so 0, 1, that becomes 1, 1, 0 OR gate. Next, 0, 1, 0, 1 becomes 0 here, 0 becomes 1. Again, last case, that is 1. You give 1, 1, the output for this is 0, 0. 0, 0 is inputted, output becomes 1. And said to be universal. Struck any basic gates NOR gate. Same as NAND gate. NAND gate is also said to be universal gate, and we can solve the basic gates by using this same procedure. You will see what that is equal to A dot B whole bar. The symbol is the logic diagram and with bubble. A, B, Y is equal to dot B whole bar. We'll see the truth table. A, B, Y. 0, 0, 0, 1, 1, 0, 1, 1. This AND gate, if both the inputs are high, output will be high. The reverse case is NAND. So, this becomes 0, and for cases, the value will be high. 1. And you can check the universality like this using the NAND gate. This is a basic universal gates. Now coming to next gate, exclusive OR gate. This is the two or more inputs and the output is high only when the number of inputs is odd. If the ones high inputs number, the output becomes otherwise be low. Y is equal to A exclusive or B. The logic diagram, this is A and B and B. Okay, truth table A, B, Y. Odd number of ones. See these two cases. Here we are having odd number of ones. So we'll get high output, and for remaining two cases we'll get low. And same as exclusive NOR. Exclusive. This gate again it is having two of, and only of is even number reverse. So exclude and the symbol with one or okay, inverted output. So now the truth table is Y 0 1 1 1. The truth is if high inputs, even now number is even number of high, there is no ones here. This even and this becomes even output, and remaining two cases B. This is side union. Analyze the equation, that is 2C. A, B, and this is OR gate. So take it and give the input A, B, and input AB output is OR with the input. So this becomes the Y. This is the realization, and you can draw any equation with a logic circuit. This can be drawn by using, that is using and. Now we'll see what are the laws of Boolean algebra. Laws of Boolean algebra. And this here of 0 and 1. That is idempotent law. That is x, if both the and or thing, then we'll get the same as x and x comes x. That is second input is inverted by using bar. What we will be getting the same output. Next is complementary. That is x is an input ORing with x bar inverted, input with inverted OR gate, then you will get 1. If you do AND operation, then we'll get 0. Next, commutative that is two inputs x and y, or in you can do either x plus y plus is nothing but or same as it is equal to y plus x. Use and x and y is equal to y x. Associative law. That is y plus z is equal to x plus y plus z, or you can get it as x plus y plus z. Same when you apply and x y and z is equal to x into y z, or is also equal to x y z. Distributive law. X into y plus z is equal to x into y plus into x plus y z is equal to x plus y into x plus no, De Morgan's law. x plus y whole bar is equal to, this becomes x bar into, or becomes and y bar, same as x and y whole bar is equal to x bar or y bar. The operation will be changing and to or, and bar is applied for both the inputs. These are the laws of Boolean algebra. Now we'll discuss about combinational circuits made up of different gates. The output of combinational circuit depends on the values at the input at any given time. Do not make use of any memory or storage. Okay, now we'll see minterms. What is a minterm? A minterm of n variables is a product of n literals. Here the literal is a variable or its complement. You can take a variable a or its complement a bar. It appears exactly once in either complemented form. That means either will get a or a bar, but not both at a time. Same as maxterm of n variables is a sum of, this is product of n literals, and here it is sum of n literals. In each variable exactly in either again true or its form. Now we'll see how to send this using the variables we are taking A, B, C, Z1, 2, 3, 4, 5, 6, 7. Now, the minterm representation presented as with small. So, first is represented as M naught, and this is written as 0 means low. So, in value A bar. Same as B bar, C bar. Next, M1 is represented A bar, B bar, C. M2 A bar, B, C bar. M3 A bar, B, M4 A, B bar, C bar. Because A value is 1, so no need to invert. B and C or zeros, so inverted values A bar, C bar. M5, that is A, B bar, C. M6 is written as A, B, C bar. M7 is written as A, B, C. Same as this, terms are represented with capital M, and M naught is written as, but here this 0 is negative logic, so it is written as A instead of A bar, and using or symbol here, this means here and symbol, okay, dot, and here or symbol A plus C. Same as all the values were written. A plus B plus C bar M2 is equal to A plus B bar plus C M A plus B bar plus C bar M4 is written as plus B plus C. M5 is written as A bar plus B plus C bar. M6 is written as A bar plus B bar plus C, and M7 is written as A bar plus B bar plus C bar. How to represent and minterms. Now coming to SOP. Sum of products. That is minterm expansion. We call it as minterm expansion or sum of products, or sum of products. That is a Boolean equation, that is logical sum of logical products. This is the logic of logical products. Sum of products. That means the expression that is the equation app or circuit and or circuit. Same as coming to POS. This is max term expansion or this is said to be product of sums. Okay. Logical product loss. product of logical sums, and this equation applies